So good afternoon, ladies. Today I'm here to discuss two topics. Polarization and optical instruments. Okay. Let's start with polarization first. The background that we need for this is EM waves. We had already discussed EM waves, and you know that an EM wave can be represented as a sinusoid of an EM wave can be represented as a sinusoid of electric as well as magnetic field. Okay. Now, let us see how it is produced. Let us see. Let's say this is a gas. We have cluster of molecules here. They are in excited state. Okay, they are in excited state, and when they come back to their ground state, they release energy in the form of EM waves. You already know that. For hydrogen, you have already studied the Lyman-Balmer-Bastian series. Do you know? You remember, right? So now, for each molecule or atom, there would be a photon generated. So there would be the light generated from this source won't be a single ray, it would be a bundle. Okay. So let us say for first ray, the electric field is oscillating in this way. For some other, we already know that these are perpendicular to C. The electric field as well as the magnetic field, they are perpendicular to the direction of propagation of light. Is it okay? Or any other EM wave? So let's say for first ray, the electric field is oscillating in this manner. For second ray, since it is a bundle, for second ray, let us say some different scenario. For third, like this, and so on. What I am trying to show here is that since it is a bundle, we would have electric field oscillating. We would have electric field oscillating in a plane perpendicular to direction of motion of light. Yeah. Okay. And as you know, all the directions are equally probable. You know, the electric field would oscillate in a vertical manner, in a horizontal manner, at any angular manner, and all the possibilities are equally likely. So all the electric field, these vectors, they would have same size. It's just that it's drawn sideways. It's a 3D diagram drawn on a 2D object, so it would look like this. But in reality, they would all be of same size, the vectors. Is it okay? So this bundle, this collection of oscillating electric field, this is the normal light which we see. But what happens? Let's say, let's call the name here. Let's write the name here. This light is called unpolarized light. Okay, the normal light is called the unpolarized light because it has electric field in all directions. Yeah, exactly. It has electric field oscillating in all directions, and that too with equal strength. Okay, the maximum electric field would have equal strength in all the directions. Okay. Now there are some devices, some instruments which we call polarizers. Yeah, exactly. There are some instruments called polarizers which can restrict the oscillations of electric field in a particular direction. Let's say in vertical direction in this case. So the light that is produced here is called polarized light, and since it has only one direction of oscillation, you know, one direction of motion and one direction of oscillation, we have kept the magnetic field out of our discussion because it makes the thing really more complex. We would be focusing on electric field only, because the same kind of thing happens with magnetic field as well. But in real world, they are like this. If this is the direction, this would be electric field, and the magnetic field would be something like this, perpendicular. Okay, so the same kind of thing happens with magnetic field as well. They are mutually perpendicular. So we'll limit our discussion to electric field only, and magnetic field will not be introduced in whole of this discussion. Okay, this light which oscillates, in which electric field oscillates only in the vertical direction, is called polarized light. Okay, let's have some few more names. Let's call it plane of oscillation of electric field. Okay, plane of oscillation of electric field. And if I draw a plane which can contain the direction of motion, if I draw a plane which can contain the direction of motion as well as the oscillations, let's draw the plane. This plane, it contains the oscillation, vertical plane, as well as the direction. This is called plane of polarization. Okay, okay, fair enough. Okay, we'll discuss in detail what are these polaroids, what happens to light. But as far as we know right now, that all the oscillations which were not in the vertical directions, they were blocked somehow. Okay, so the intensity would be lower. You know it already. Okay, the intensity would be lower. You can understand it. Okay. Apart from this, one more thing I would like to show here is, this is not the only way. This is linearly polarized light. This is not the only way to polarize a light. Okay, there are other two forms. One is called circularly, even though they are not in syllabus, it's worth discussing. There are other two forms, circularly polarized as well as elliptically polarized. In circularly polarized, what happens is, the electric field vector which was oscillating in vertical plane, it would be like this. One time it would be oscillate in slightly at some angle, slight angle, then further it will tilt. Okay, so it's like oscillation at one point of time. The propagation is going in positive x direction. The oscillation would be at one time like this. At some other time, it would be oscillating like this. At some other time, like this. So if I draw the head of this vector, it forms a spiral of this type. The head, okay? It forms a spiral of this type. The oscillations, once it would be oscillating like this, then tilted, then again tilted, and so on. So the head would be in the form of a spiral, and if you see from this direction, the pattern, the locus of this head would appear to be a circle. That's why the name circularly polarized. Okay. In case of a elliptically polarized light, the magnitude, the maximum possible magnitude of electric field also changes. So the size would keep on increasing and decreasing. It is like the head is rotating and the size is also decreasing, increasing, decreasing. So you can see the pattern. If we see in this direction, that would appear, it is a circle like this. From front on, if I see, the size would appear to be the object would appear to be a circle. Okay, the electric field vectors rotating like this. In this scenario, elliptically, the same thing happens. Oscillations, they start vertically, tilt through some angle, then again tilt, then again tilt. They'll keep on tilting, but the size also varies. In this case, if I see from in front of direction of propagation, from this direction, what pattern I would receive is some this kind of pattern, an ellipse. So the electric field starts with this, then reduces in magnitude as well as tilts more and reduces, minimum magnitude increases like this. Is it okay? These two are called circularly as well as elliptically polarized lights. Okay, okay. So can I erase this? The definition of polarization. What would be the definition of polarization then? What? The phenomena of restricting the electric field oscillations in a particular direction. Exactly. The phenomena of phenomena restricting the electric field oscillations in a particular direction is called polarization. Okay, and the instruments which do it are called polaroids. Okay. Acha. We'll study polarization due to some ways. Okay, polarization through some ways, and we'll study what happens to the intensity of light when polarization happens. Is it okay? But let's see first some real life examples of polarization. Okay, let's see first. Do you know what is a Polaroid? Polarizing glass. Polaroid. Some people they use specs. Just a second. Okay, some people they use polarizing glasses. Okay, what do? They actually, sun emits light which is not polarized at all. What happens is that our atmosphere, the air particles, they scatter light, and due to that the sky is blue in color. जानते हो ये चीज? You already know this, right? The sky is blue in color because of scattering. And when this scattering happens, one more thing changes. It is the plane of oscillation. The light no longer remains uh, unpolarized. It becomes partially as or plane polarized in scattering. Okay, what happens then is if this light falls into our eye, it is dangerous actually. Okay, so these glasses, which the Polaroids, these glasses, they cut this polarized light, and they are designed according to the plane of polarization. Let's say if light has plane of polarization vertical, we design glasses which would have plane of polarization horizontal, so that this light, the polarized light, this is eliminated, and we receive only unpolarized light. Okay, we'll see some examples after reflection that how to see a polarized light. Okay, let's see some ways of polarization. The first one, it is polarization. Is it visible enough? No. Polarization by reflection. Okay, let us say this is a glass surface. Okay, here glass. Not only glass, it can be any plane surface, but there should be some difference in optical density. So air with water or air with glass, that will do. Okay, let us say we send a ray at an angle I. It reflects such that the angle of reflection is still I, and a part of it transmits into the medium. Let's call it R. The refractive index is mu. Okay, This, you know, this happens. Okay, a part of light is reflected from the surface and a part is transmitted, and that's why the bottom of a swimming pool, it appears shallow, you know. Okay, so a guy named Brewster, he experimented on this for different range of angles from 0 to 90 degree. He found that actually when the reflected as well as refracted rays are perpendicular to each other, when they are normal to each other, the reflected light is plane polarized, and the plane of polarization is perpendicular to the surface. One more thing I would like to add, representation, let's say, because it would help a lot. Representation, we already saw that normally the light has oscillations like this. Normally the light has oscillations like this. What we can do is any electric field vector which is at an angle theta with the vertical axis, we can split it into two components, the horizontal, the vertical. Okay, in this manner what we can do is we can split all the electric field vectors into vertical as well as this horizontal, the z axis wala. Okay, into two components, one along y axis and one along z axis. Okay, so the net effect would be we would have one oscillation, big oscillation in vertical and one big oscillation in z axis direction. Okay, we represent this in 2D as a dot with vertical oscillation. The dot indicates oscillation into and out of the plane, okay, perpendicular. So this guy, this Brewster, he experimented. If unpolarized light was being incident, a part of it enters and a part of it leaves. The reflected ray has components only into the plane. Okay, has components into the plane. Okay, let's define a plane. It contains the reflected, the incident, the refracted as well as the reflected ray. Is it okay? So let's call it the plane of refraction or reflection. Okay, the plane of reflection as well as refraction. The oscillations would be perpendicular to this plane. They would be into and out of the plane. Okay, so you can see they would be horizontal, but along y-axis, along z-axis. Sorry, is it okay? They would be horizontal, but along z-axis. Okay, and we know the angle is 90, so we know that actually r plus r dash would be 90 degree. These two angles, and r would be what, 90 degree minus, we knew r dash is I. Now by Snell's law, one sine I is mu sine r. You already know it. Sine I is mu sine 90 minus I, and this thing would be mu cos I. Okay, so the result we get is tan I is equal to mu. So at a particular angle, when this condition is satisfied, the light which is reflected, the reflected light is plane polarized with oscillations perpendicular to plane of refraction. Is it okay? Okay, so here we write oscillations would be perpendicular to plane of refraction. Okay, but only at this condition. So at this particular angle only, we call this angle as IP, the polarizing angle. Is it okay? Okay, We call this angle as the polarizing angle, and the oscillations would be perpendicular. What about this, the refracted ray? What about this? The original light has oscillations. The original light had oscillations in this direction and into the plane as well, into and out of the plane. We have extracted some of the into and out of the plane oscillations and sent them here. So the remaining oscillations would be like this, but obviously some of them would have a little bit of into and out of the plane oscillations as well. Okay, the original light had equal oscillations in this direction, okay, and into and out of the plane. We have extracted the into and out of the plane oscillations. So what we are left with is the oscillations in, yeah, in this direction, as well as some oscillations in into and out of the plane. So this, in this, the strength of electric field in this direction would be stronger, while the strength of electric field in into the plane and out of the plane would be a lot weaker. Okay, and this kind of situation in which there are two types of electric field, not equal strength, this is called partially polarized light. Okay, now this is the most important application fact, basically related material, which we can see in real life: polarization by reflection. Okay, let's have a look. Is it okay? Can I raise it? Let's say we have a pond, air, water interface. Sunlight comes from here, and it is reflected, some part is refracted. You know that at one particular angle at IP, this would be 90° and this would be polarized. We can calculate the value of IP in this case because we know mu is 4/3 for water. We can calculate this. Is it okay? So what happens is, if you are somebody is asking the question, how are then getting refraction is taking place? Refraction, the reflected light is totally polarized, the refracted light is not. Somebody is saying that refraction is taking place. It is not because of refraction, it is because of the reflection only. So at this angle, we can calculate the polarizing angle. So at this angle, what we will be able to find, that if we see this human eye, and this is the light that I was saying that it is harmful for our eyes. So what would the oscillations are into the plane and out of the plane. So what would a Polaroid do? A Polaroid would have a plane in this direction, perpendicular. It would block the into and outward oscillations. Okay, okay. We can see, we can, in reality, we can feel it. Let's see, you have a river, not a river, it's actually flowing. Let's see, you have a lake or sea. In this case, the horizon that appears to be shining. Okay, if we see water surface at a large distance, which is at a large distance, the portion of it appears shining. Okay, and it hurts our eyes. The same thing happens when light enters into eye, which is reflected from car surfaces, their glasses. Same type of glare, that is called glare. Okay, that is nothing but the plain polarized light. It is harmful. You feel it. Okay, the eyes are hurt little. in fact, one more thing you can see, if this kind of appearance is happening, this kind of thing is happening, that light is coming at an angle and getting reflected, and you stare at the lake surface, you won't be able to see anything under the surface. Okay, but if you wear a Polaroid, you can see that under the surface, you can see the fishes or the water life under the surface. It is clearly visible. Why? Because the Polaroid cuts this highly intense unpolarized light, and it allows the light which is coming from down there to enter the eye. Okay, that's why we are able to see it, not with naked eyes. Okay, so this is the first part. Let's have a question. Polarization. Let's have question 2. Question 2, please. When light of certain wavelength is incident on a plane surface of a material at a glancing angle of 30 degree. What does glancing angle mean? Glancing angle is this. Okay, incident angle के opposite जो बचेगा ना ये. Okay, this is glancing angle actually. Okay, this is at glancing angle of 30 degree. So what it simply means is that incident angle would be 60 degree. Okay, the reflected ray is found to be completely polarized. Find refractive index and angle of refraction. Okay, this is a very simple question. Online people, I'm expecting answers. The answer would be √3. Mu would be √3, and angle of refraction 30 degree. That's it. This is happening actually. The glancing angle is said to be 30 degree, and so incident angle would be 60 degree. This is the refracted light. Is it okay? We know this would be 60, and we know that for polarizing angle, tan IP is equal to mu. So tan IP is equal to mu. You can put IP as 60 degree, mu would be √3. To find this, you can use Snell's law, and you can directly use this one as well. R is equal to 90 minus I. Okay, it was an easy one. The questions in this chapter are not that difficult. It's just that it is related a little bit to EM waves, so that's why it appears to be a difficult chapter. Is it okay? Can we continue? Second way is using Polaroids. Okay, ways of polarization we were studying. Second one is using Polaroids. The property is called dichroism. So they are dichroic crystals. They are dichroic crystals. Okay. What are these dichroic crystals? Let me first discuss that. Okay. Dichroic crystals are long chain hydrocarbons, either hydrocarbons or some crystals which have long chains. Ionic form may also. Okay, okay, they should have long chains. So let's say they have a long chain like this. Okay, and when light is incident, we have two chains. When light is incident into in between them, what happens is, let's say light has oscillations of this as well as this. The direction of motion of light is into the plane. These oscillations which are parallel to the dichroic to the chain length, they induce, because they are changing, right? They are changing, the electric field is changing, that induces some currents in the crystals, in the chains. So due to this electric field, a current is induced here. A changing electric field produces a changing magnetic field, which in turn can produce current, EMI. Do you remember? Yeah, electromagnetic induction. So what happens is, a current is induced in this as well as in this direction. Okay, so this electric field, this oscillation of the electric field vector, this is absorbed, because what happens is, when current runs through these chains, the heat is dissipated. So where would this heat come from? From the electric field itself. Okay, when current run through these chains, what happens is, heat is liberated, and that heat comes at the expense of electric field energy. So this as it enters and enters through the crystal, the size of this electric field, it reduces and gradually becomes zero. What we get is, finally, after passing through it, oscillations of this type only. Getting my point? Okay, so this behavior is called dichroism. It is shown by tourmaline. A few you might be knowing tourmaline, and some a lot complex names, iodosulfate of some compound, iodosulfates of some compounds. So the primary thing is tourmaline. Okay, so what we do is, we cut tourmaline into proper proportions, proper thickness, so that it can absorb. It is not going to happen that the first chain itself absorbs whole of the electric field parallel to its length. Is it okay? What we do is, we maintain some thickness, and due to that, when light crosses that thickness, this portion of electric field is absorbed, cancelled. Okay, we get this. So we cut tourmaline into crystals of proper thickness. Okay, and now let's see what happens if light of this type is incident on a tourmaline crystal. We generally keep the shape hexagonal. It is our representation. Let's say in this hexagon, we have chains like this. Okay, into the plane of paper. And what would happen after it crosses the crystal? What would happen is, the oscillations which were into the plane, they would get absorbed. Okay, let's see. Let me draw a bigger diagram actually. Okay, let's say the oscillations are like this. Okay, vertical and into the plane. Okay, the into the plane oscillations, they are absorbed by these chains because they are parallel actually. Okay, parallel to the into the plane component. So what we get is this. Okay, so if we draw a plane, the electric field components, they which come out are parallel to this plane, vertical plane. This plane is called, which is perpendicular to the length of dichroic crystals. This particular length of chains actually, it is perpendicular to the length of chains. This is called transmission axis. Any electric field parallel to transmission axis would be transmitted completely, and one more plane would be there. Okay, it would be perpendicular like this, slicing like this, parallel to the board. Okay, not parallel to the board exactly, actually ऐसा होगा कुछ ऐसा, slicing like this into the plane but horizontal. Okay, in this case what would happen is, this plane, in this plane, the oscillations which are parallel to this plane, they would be absorbed completely. This is called absorption axis. Okay, it's not mentioned generally, and actually we need not do that because they would be perpendicular. Okay, they would be perpendicular. If we know the transmission axis, we already know the absorption axis as well. So if any oscillation is perpendicular, is parallel to transmission axis, it is transmitted. If it is perpendicular to transmission axis, it is completely absorbed. Okay, so oscillations parallel to dx axis transmitted, and oscillations perpendicular to tx axis absorbed completely. Okay, there are few other ways. There are few other ways which are theoretical, and some of them are out of our syllabus. So I'll just discuss it. One is due to polarization. Why double refraction? Let's say it's a crystal of calcite. It's a crystal of calcite. Okay, let me draw better shape. It is a crystal of calcite, and an unpolarized light is incident on it. What happens is, calcite has this special property. It splits the light into two components. It splits the light into two components. One that follows the laws of refraction. Okay. One that follows the laws of refraction. मैं थोड़ा इसको बड़ा बनाता हूँ so that थोड़ा अच्छे से discussion हो जाए. It would bend toward normal. Is it okay? Like this. Okay. And let's call it the ordinary ray or the O ray, and one which doesn't follow. It goes straight, whatever may be the shape. It is called the extraordinary ray. Extraordinary ray or the E ray. Okay, extraordinary ray or the E ray. This is the O ray. It again refracts and gets parallel to the E ray. Is it okay? You know, the E ray in this case, This is a special property of calcite crystal that it splits the ray into two parts, the O ray and the E ray. The E ray here, which transmits finally, is actually plane polarized, while the O ray would be partially polarized, which means it would have more of these dots but less of these verticals, right? Okay. Okay. Now, if you see the object, if human eye is here, okay, if human eye is here and we see both the rays, we will see actually two objects. Okay, corresponding to both the rays, we will see two images. Okay, what happens is, if increase the thickness of crystal, will it affect plane of polarization? No, I don't think so. If increase thickness of crystals, in this case, it won't affect plane of polarization, because the line, the chains are aligned. It is a crystal actually, and the chains would be aligned in a similar manner. You do remember the crystalline solids in which we have a long-term pattern. Okay, so the chains would be aligned in a similar manner itself. Okay, we have two rays, the E ray as well as the O ray, and to a normal eye, we two images would appear, one in this direction and one in the original direction. Okay, so what we do is we generally make some arrangement so that the O ray is blocked and only the E ray appears. Okay, so what we see is only one ray, only one image, and that too formed due to plane polarized light. Okay, now if we there was one question that if we rotate this, what would happen? Since if we rotate this about the original direction, if we rotate the calcite crystal about the original direction, that is like this, what would happen? What would happen is, if you rotate it, the extraordinary ray would keep coming in the straight direction. So this image formed here would be of would be located at the same position, but as it rotates, the O ray rotates with it. Okay, so the image formed by O ray would rotate as well. So this would rotate. So what would we see? We would see two images, one at center and other rotating around. Okay, so that's why, to prevent this kind of happening, we try to block the O ray by blackening some part of the surface. Is it okay? So a crystal cut in proper form forms a Nicol prism. Nicol prism is the original polarizer which we talked in the first part. Okay, the most commonly used polarizer is Nicol prism. It's made up of calcite crystal. In fact, not purely calcite, some compound form, in fact, or mixture. So we don't have interest in that. Is it okay? Is it clear? Now let's see the intensity of polarized light. Okay, intensity of polarized light. It depends. In first case, it depends on what was the original source actually before the incident light, whether it was unpolarized or polarized. It depends. Okay, so we have this light which is incident on a polarizer. Let's say these are the transmission axes, and we get plane polarized light, right? But depending on the original light, the incident light, whether it was unpolarized or plane polarized, we get different kind of intensity formulas. So let's see if the incident light was polarized, was plane polarized. Okay, if the incident light was plane polarized or linearly polarized, which means what? We have light with single oscillations. Okay, let us assume that this light makes an angle theta with the transmission axis. Okay, let us assume theta is the angle between angle formed uh, by direction of oscillation with transmission axis. Okay, with transmission axis. What happens is, in this case, obviously the light would come, either it would come parallel to the transmission axis or it would not come at all. Okay, so let's break this electric field E naught into two components. Let's say, let the amplitude of electric field be A. Okay, I'll redraw it. Okay, like this. The incident light has an angle of theta, has oscillations at an angle of theta with the transmission axis. Let's call the amplitude as A. Okay, A naught, let's call it. So let's break it into two components. It would be A naught cos theta and the other one would be A naught sin theta. Okay, A naught sin theta would point into the plane or out of the plane. It won't point in the direction parallel to motion of light. Is it okay? Don't draw it in this manner. It would be wrong. Electric field can never be parallel to the direction of motion. Okay, so it would be into the plane. A naught sin theta is into the plane. Okay, so now we can see that when light passes through the polarizer, okay, what happens is A naught sin theta component would get absorbed while A naught cos theta would come out. Okay, you know it already. Okay, the intensity, incident intensity, is this. The incident intensity is proportional to A naught square, or we can call it I naught is equal to K A naught square. K is a constant. Okay, so this is for incident light. For transmitted light, I1 would be proportional to, let's call it A square, or we can say I1 is equal to K A square or K A naught square cos square theta. This is I naught cos square theta. Okay, now this thing, this is called law of Malus. Okay, this is called law of Malus. So from this law we can see that actually the maximum intensity is received when theta is 0. Okay, I1 is equal to maximum when theta is 0. What it means is that the initial oscillations were parallel to transmission axis. Okay, I'll write it there, some other place. Shall I erase it? Okay, हो गया ये, है ना? So we know law of Malus is this: I1 is equal to I naught cos square theta. Okay, so if theta is 0, मतलब क्या? Yeah, initial oscillation parallel to transmission axis. Okay, all of it would be transmitted. whole of the light would be transmitted. So in this case, I1 would be equal to I0 is the maximum possible value, case 1. Case 2 would be if theta is pi by 2. Okay, initial oscillation is perpendicular to transmission axis. What would happen? I1 would be 0, no light. Is it okay? Okay, so if we rotate a Polaroid, what would happen is, if initially the oscillation and the transmission axis they match, if we rotate them now, gradually the intensity would decrease, because the plane of the oscillations would be in this direction itself. In that case, initially, let's say the oscillations were like this, and this was the transmission axis. If we rotate it slowly, the transmission axis would tilt, the angle between original oscillations and transmission axis would increase, and when it reaches pi by 2, what would happen is intensity would be 0. After that, it will again increase. Why? Because we have a cos square thing. So even if the angle becomes more than pi by 2, square would be positive. Is it okay? So it will increase again. Okay. On this, let's have some questions. एक मिनट नीचे नहीं, सेकंड पेज एक बार देखिए. In second page, let's have question number 3rd. This one. Plane polarized light. Plane polarized light is passed through a Polaroid. On viewing through the Polaroid, we find that when the Polaroid is given one complete rotation about the direction of incident light, what happens? Tell me the option. Online people, please, you also try. देखिए ऑनलाइन में आया क्या किसी को नहीं. Okay, someone said A. Somebody is asking a question actually. अच्छा, आंसर A. सब लोग A ही बोल रहे हैं. Let's check what happens. This is our crystal, the Polaroid. Okay, मैं इसको थोड़ा सा क्लीन बना देता हूँ. Okay, let's assume that it is rotating like this. The oscillations are vertical, but the plane is tilting. The oscillations are vertical, the plane is tilting. Okay, so initially the intensity would be maximum because they are matching exactly. Now, as the plane tilts at pi by 2, the intensity would be 0. Afterwards, it would again increase. Okay, okay. So let me draw it. This, let's call the red marker as the plane of oscillation. It is rotating like this. The plane of the transmission axis, it is rotating like this. The oscillations are in the same manner. At pi by 2 angle, okay, at pi by 2 angle you get intensity 0. But as the axis rotates at 180-degree angle, the situation is exactly similar. What happens is the point A and B, what happens is after 180-degree rotation, they get inverted. The situation would be like this only. B point comes up, A point comes down. It doesn't matter to light. What matters to light is that the transmission axis, they should remain aligned with the oscillations. They are once again aligned. So in half a cycle, we get twice, maximum intensity for the second time. Again, as it rotates, again at an angle of 270 degree, Okay, the intensity would be 0. So if it is given one complete rotation, we would experience intensity, maximum intensity twice, as well as 0 intensity also twice. So the answer would be D. Okay, right? समझ आया? अच्छा, अब let's discuss the next question. Please थोड़ा सा कर दीजिए. A beam of light AO is incident on a glass slab. The refractive index is 1.54 in a direction making an angle as shown. Okay, the angle is 30 degree. The glancing angle. Okay, the incident angle would be what? 60 degree. Okay, so if the reflected beam OB is passed through a rotating Polaroid. Okay, what we would have? Let's check what it is given. This ray is coming at an angle 30 degree. The I would be 60 degree. Okay. This also 60 degree and something like this. So we are not concerned with the refracted ray. We have a Polaroid here. Okay. We have a Polaroid here and it is rotating. So let's say the axes are like this. It is rotating like this. ठीक है. अब देखते हैं क्या होगा. We already know that at polarizing angle tan IP is equal to mu. है ना? Let's calculate the polarizing angle for glass. It would be tan inverse 1.54. Okay, tan inverse 1.54. It, you know, would be approximately 57 degree. ये इतना आता है. How can I say? What I need to know is that if I use 60 degree as polarizing angle, let us assume that 60 degree is the polarizing angle, then in that case tan IP would become tan 60 or √3, यानी कि 1.732. Okay, so if 60 degree had been the polarizing angle, then refractive index would have been 1.32. We have refractive index this, so obviously the polarizing angle would be less than 60. We know it. The polarizing angle would be less than 60. So we have, the light is incident at an angle of more than polarizing angle, which means what? That this light won't be plane polarized. What would happen is it would be partially polarized. More number of dots, but still some vertical oscillations as well. Okay. Okay. When the transmission axis is vertical, is parallel to these vertical oscillations, what happens is only the vertical oscillations are allowed. These are very few in number, right? So the intensity would be minimum but not 0. Now when we rotate the Polaroid, the intensity increases, and when the transmission axis, they become like this. Like this, the transmission axis, they become into the plane. Okay, when the transmission axis become into the plane, these dots that are oscillations into the plane and out of the plane, they are allowed to go through, and since they are the maximum amount, they are a large number, so the intensity would increase considerably. So intensity would be maximum when the transmission axes are aligned along the into and out of the plane scenario. Okay, and the intensity would be minimum when the Polaroid, Polaroid is arranged so that the transmission axes are parallel to the plane of these vertical wala oscillations. Is it okay? Is it okay? Okay. The intensity is minimum when transmission axes are like this, parallel to these vertical oscillations. The intensity is maximum when the transmission axes are into the plane and out of the plane, parallel to the oscillations. Okay. So we see that in any scenario the intensity won't be 0. Is it okay? Is it okay? This is the first time you have encountered a question which has partially polarized light. Okay, so we see the options. The intensity is reduced to 0 and remains 0. No, not an option. The intensity decreases somewhat and increases again. Fair enough. The intensity decreases to 0 and increases again. This is wrong. This happens with plain polarized light, but not with unpolarized. No, partially polarized light. Hai. Okay, not with partially polarized light. And D is no change in intensity. That is obviously wrong. Okay, so B is the correct option. Okay. Okay. Shall I raise? Let's discuss the B part. The B part is we are trying to find the intensity of polarized light when unpolarized light is incident on polarizer. Okay, when unpolarized light is incident on polarizer. So let's see, let's say this. This is our prism. Okay, let us say unpolarized light is this. Okay, okay. Let me draw it in the original manner. Vertical oscillations, the into and out of the plane oscillations would be some, okay, some oscillations would be at an angle, some at more angle. So this would be the plane of oscillation. Is it okay? This would be the plane of oscillation. So now all these oscillations, as I said, all these oscillations can be divided into two parts. One which is parallel to transmission axis and one which is perpendicular. Okay, let us see. As I said earlier, that if we have an oscillation at this angle theta, and these are the tx axis, what happens is the a cos theta passes through, a naught cos theta passes through, and a naught sin theta is blocked. We already know it. Okay, so this is for one single oscillation. What about this collection? In this collection, we would have oscillations which have an angle from 0 to pi by 2 with the transmission axis. You know, there would be one oscillation which would be vertical, parallel to the transmission axis. There would be one oscillation which would be slightly tilted, then one which is more tilted, and so on. One oscillation would be perpendicular to the transmission axis. Okay, so we have angles in the range 0 to pi by 2. Is it okay? So the intensity for single oscillation, we know the intensity is I naught cos square theta by Bandel's law. So for this bundle, intensity for different parts would be different, and we can calculate the average. You do remember that there was one averaging function cos square theta for one complete cycle. याद है कुछ ऐसा? We did it in AC. Averaging में क्या कर रहे होंगे हम लोग? We 0 से 2 pi by 2 pi तक हम ये करने वाले हैं. Is it okay? 0 से 2 पाई तक हम लोग इंटीग्रेट करने वाले हैं. हमने ये AC में पढ़ा था. ओके, अगर किसी को याद नहीं है तो एवरेजिंग फंक्शन यही होता है. क्या करते हैं हम लोग? वी ड्रॉ द ग्राफ, वी टेक स्मॉल स्लाइस, हम उसके लिए वैल्यू निकाल लेते हैं. लेट्स से इट इज ft dt. We integrate it for the given range and we divide it with the time duration. What average means is कि एक सिंगल कांस्टेंट वैल्यू जो सेम एरिया दे रही होती फॉर द सेम रेंज. सो वी आर ट्राइंग टू कन्वर्ट दिस वेरिंग ग्राफ इनटू अ कांस्टेंट ग्राफ. T1 to T2 such that the area is still the same. For the same range, the area is same. Okay, this is the average function. This upon this, and we already knew that the average would be half. How you can integrate it? It would be 1 minus cos 2 theta by 2, है ना? 1 minus cos 2 theta by 2, and 1 by 2 pi integral 1 minus cos 2 theta by 2 d theta 0 से 2 pi. One, sorry, my man. Actually, it doesn't matter. That's why. Let's check. We have 1 by 2 and we have cos 2 theta by 2. This is a constant function. इसका integral क्या होगा? You can calculate. Okay, theta by 2, and you can put the values as well. इसका integral क्या होगा? Let's check. Cos 2 theta है ना? ये नहीं, इंटीग्रल करने की जरूरत क्या है? नहीं, गिवन रेंज के हिसाब से मैं पूछ रहा हूँ एक्चुअली. इसका इंटीग्रल क्या होगा? It is a graph of this type. In 0 to 2 pi angle, this would have 2 cycles. क्योंकि जब 2 थीटा ले लेते हैं तो क्या होता है? टाइम पीरियड आधा एंड फ्रीक्वेंसी डबल, यही होता है. Is it okay? तो 2 थीटा लिया तो इसका टाइम पीरियड हो गया है अब पाई. So it would repeat after pi. So इसके 2 cycles ऐसा होगा. If you are integrating over 0 to 2 pi, you are actually adding the positive as well as the negative areas, and you can see in cos the lobes are of equal size. They would cancel. So cos 2 theta would have integral value 0. We already know this. Okay, this would be 1 by 2 pi into theta by 2, and if you put 2 pi in theta, you get 2 pi by 2. Half आया. Okay, so अगर हम यहाँ एवरेज इंटेंसिटी निकाल रहे हैं for a single oscillation, intensity जो आई थी वो ये थी. This was the intensity. For a complete bundle, the average intensity would be how much? It would be average of this thing, which we know already, I naught by 2. We have calculated this. Okay, so if an unpolarized light is incident onto a prism, onto a polarizer, sorry, so what happens is only half of the intensity comes out. Okay, let's think of it in some other manner, in a simple logic. सीधी सी बात समझो. We had oscillations in all possible directions. Okay, let's say this had I naught intensity. Okay, the unpolarized light had, ये रुक जाओ एक मिनट, पूरी बात सुन लो. Okay, the unpolarized light had I naught intensity. अगर initial intensity I naught थी, आधी intensity parallel to transmission axis and आधी intensity perpendicular to transmission axis रही होगी ना, and the intensity which is perpendicular to transmission axis, it is eliminated, absorbed. So the parallel to transmission axis, that is only transmitted. So you know that actually theoretically it can be proved, and we have done it mathematically as well. This is the final intensity after this is transmitted through a polarizer. The unpolarized light is transmitted through a polarizer. Can we you want to finish it off? Questions? So we have some questions. Sheet 1. I'll be discussing 1 or 2 questions only because of the time constraint. You can try the other questions on your own. They are not very difficult. Let's try the first one. It's a very common question, written everywhere. The first one. We have 2 crossed polaroids. Crossed polaroids are 2 polaroids which have their transmission axis perpendicular to each other. So let's draw the diagram because it needs a diagram. कुछ ऐसा है एक polaroid. Okay, the other one is like this. Okay, perpendicular hai. It's not that easy to show perpendicular in on a board. Okay, first one has transmission axis vertical, the second one has transmission axis into the plane. Okay, so they are perpendicular to each other. What happens is derive an expression for of intensity through the last Polaroid if the middle Polaroid is rotated. अच्छा ये मैं बीच में एक line miss कर गया. We have a third Polaroid in between. Okay, third Polaroid है and the angle is not given, so I'll assume that it has some angle. Something of this sort is happening. Let us say it has an angle theta with vertical direction, the first Polaroid. Okay, okay, so it's like this. First one is vertical, first one has vertical transmission axis, second one has tilted, third one is 90 into the plane. Third one is like this. So if this has theta angle with first one, the third one has, it's like this kind of arrangement. These two, the first two Polaroids are like this. So if it has theta angle with the first one, it would have an angle of 90 minus theta with the second one. This is into the plane, into the paper direction. Okay, so it would have an angle of 90 minus theta with into the paper direction. Is it okay? Let's say we have I naught here, unpolarized light. Okay, it wants us to derive an expression for intensity through the last Polaroid if middle Polaroid is rotated while unpolarized light is incident on the first. So unpolarized light is incident on the first, it is being rotated. Achha, I naught is the unpolarized intensity. So through the first Polaroid, intensity would be I naught by 2. Let's call it I1. Okay, let's call it I1. Through the second Polaroid, if the angle here is how much? Angle is theta. The intensity, it is the light here is plane polarized. Do you know it? You know it, right? The light would be plane polarized, and what is happening is this is a plane polarized light, and the axes are aligned at an angle theta. The intensity that would come out is I naught by 2 cos square theta. Intensity here would be I1 cos square theta or I naught by 2 cos square theta. Okay. Now for the third Polaroid, the angle is 90 minus theta. Okay. So the light here is at an angle of this, but the Polaroid is into the plane. The angle is 90 minus theta. So let's call it I2. So for the third Polaroid, the intensity that comes out would be I2 cos square 90 minus theta, or I2 was I naught by 2 cos square theta. This would be sine square theta. We can still simplify it. We can write it as I naught by 8 into 2 sine theta cos theta. Sine square 2 theta. This is the final intensity. So if the Polaroid is rotating with an angular velocity of omega, we know theta would be omega t. We can replace it. Final intensity I3 would be I naught by 8 sine square omega t. And you know when the intensity would be maximum? एक second, 2 omega t होना चाहिए था. The intensity would be maximum when sine 2 theta would be 1. Okay. Okay. So I3 is maximum when sine 2 theta is 1, or 2 theta is pi by 2, or theta is pi by 4. So when the middle Polaroid has axis in between. So what happens is first Polaroid has axis vertical, second one has axis horizontal, and the third should have in axis. In this case, the intensity would be maximum. Okay. From this discussion, we can also calculate when there are more number of Polaroids. We can still calculate. It will be a sequence. Okay. Is it okay? Let's discuss last question. Let's discuss the question fourth. Okay, let's discuss question fourth. This is the last question I'm going to discuss. Rest you would have to do rest of them. A mixture of plain polarized light and unpolarized light finally, sorry, falls normally on a polarizing sheet. On rotating the sheet about the direction of incident beam. Okay, so about the direction of incident beam, you are rotating it perpendicularly. Okay, the transmitted intensity varies by a factor of 4. Okay, which means what? The maximum intensity would be 4 times the minimum intensity. It is just that. Find the ratio of intensities IP and IO respectively of polarized and unpolarized components in the incident beam. Okay, now अभी पहले यही फाइंड कर लेते हैं, फिर नाउ की बात बाद में देखेंगे बात. Okay, do please. Online people, you also please. कुछ लिखा है? Sir, please explain again the polarized part. काफी देर पहले हुआ है, तो 19 मिनट पहले. पता नहीं उस टाइम पे क्या चल रहा था. मे बी द क्वेश्चन जो ऑब्जेक्टिव क्वेश्चन था जिसमें अनपोलराइज्ड लाइट थी, मे बी वो था. You can ask, somebody has asked the question at 2 DPS Pradhan Nagar about the partially polarized part. You can ask the question, yeah, page 2 question 4. आप लोग एक मिनट, चलो मैं करवा ही देता हूँ पहले पूरा. क्वेश्चन 4 लास्ट वाला था. Yeah, this one. In this question, what was the problem? What the problem was that the angle at which light was incident was not polarizing angle. Okay, light is incident at an angle of 60 degree in this case. Okay, but the angle is not polarizing. Okay, polarizing angle for glass is 57 degree. We discussed it. Even if you don't know, you can still get the value that at angle 60 degree, the refractive index should be tan 60 degree or √3, but it is lesser. So that means polarizing angle for this would be lesser. Okay, which means the light which is the since the angle is not polarizing angle, the light is not linearly polarized. It's not plane polarized light. The light would be partially polarized. Okay, the light would be partially polarized, and because and since the Polaroid is rotated, at some point the minimum oscillations, those oscillations which have been sent into the refracted ray, and only some part of them has come in the reflected beam, only at some point of the time they will be transmitted. They would be very less in number, so intensity would be low but not 0. And in the other case, what would happen is when it is rotated at such an angle that the transmission axis of Polaroid is into the plane of paper, that is to the parallel, it is parallel to the majority of the oscillations which are reflected. Okay, in that case the intensity would be maximum. Okay, if in case you have doubt, then you can please post it on helpline here, I guess. Yeah, post it on the helpline. I'll take up the doubts on helpline. Okay, I'll take up the doubts on helpline. Can we continue with the question, please? The question says incident light is polarized plus unpolarized. Okay, and we have sent it on a polarizing sheet. We may call it a polarizer. So this is the polarizer. Okay, the transmission axis. We are trying to rotate them. We are trying to rotate it as well. Okay, as we rotate it, the maximum is to minimum intensity has a factor of 4. The intensity varies by a factor of 4. That means the maximum is to minimum intensity has value 4 ratio. Okay, you have to find the intensity of each of them. Okay, it appears very difficult, very long question, but let's see. Let's split them. When only unpolarized light is sent, when only unpolarized light is sent, what we have intensity I naught by 2. When only polarized light is sent, okay, the intensity varies according to this function cos square theta. Okay, so this will increase or decrease, but not the intensity of the intensity that comes out from the unpolarized light. Okay, whatever may be the orientation in this case, when unpolarized light is sent, okay, whatever may be the orientation of transmission axis, what happens is only half of light comes out. So what happens is the total intensity would become I naught by 2 plus IEP cos square theta. This would be minimum when cos theta is 90, when theta is 90, cos theta is 0. So this would be IP by 2, I naught by 2, sorry. And this would be maximum when cos theta is 1 or theta is 0. Okay, now this ratio is 4 times. So you know I naught by 2 plus IP is 4 times I naught by 2 from this. And from this you can solve, ye hoga kitna? IP is how much? 3 by 2 I naught. Okay, so ratio, if we find IP by IO is what? 3 by 2. Okay, there is another part. Now the axis of polarizing sheet is fixed at an angle 45 degree with the direction when the transmitted intensity is maximum. Okay, so at 45 degree angle, 45 degree angle fix kar diya gaya. Okay, you have to find total intensity of transmitted beam in terms of IO. Okay, so it is the intensity. Now this is the intensity. अब यहाँ 45 fix कर दिया आपने. What would happen is cos square 45 would become 1 by 2, 1 by root 2 का square. So the intensity in that case would be I naught by 2 plus IP by 2. Okay, and we already know that IP is root 3 is 3 by 2. So this is 3 by 2 I naught and half as it is. So what we get is 3 by 4 plus half, 5 by 4 I naught. Okay. So with this we end the polarization part. Okay, with this we end the polarization part. Can I erase it? It is not about the intensity only. Polarized light is half the intensity I know of unpolarized light. Somebody is asking that plain polarized light has half the intensity of unpolarized light, then why is it harmful? See, what happens is in our eye, the retina cells, they have this kind of arrangement. Okay, the vertical dimension is less, but the horizontal is more. Is it okay? And you know, all these objects which have flatter surface, all these objects on the earth which have flatter surface, they will produce oscillations in horizontal way. We just, do you remember it, after reflection the ray had this kind of oscillation, okay, into the plane. So horizontal basically parallel to the reflecting surface. So since most of the surface on Earth which produce glare, they are horizontal, what would happen is we would see plane polarized light which would have horizontal oscillations, this kind of oscillations. Okay, okay. Now since retina is more sensitive to the horizontal portion, intensity is low. What happens is the intensity is low. So you know when intensity is low, the pupil expands according, it adjusts according to the intensity. Okay, so the pupil has expanded to adjust for the half intensity, but actually what happens is the electric field which the retina cells they encounter is still the same in horizontal direction. Okay, so it's like that somebody is forcibly opening your eye for twice the intensity. What happens is, you know, no, the pupil size is twice the size, but the intensity in horizontal direction it is still the same. Obviously it is going to affect. Okay, so that's why. Okay, now let's continue with the optical instruments. Before we start optical instruments, let's first have a bit of the background on human eye. Okay, पहले थोड़ा सा human eye की बात कर लेते हैं, फिर हम लोग optical instruments की बात करेंगे. Optical instrument, मतलब the best optical instrument in the world is human eye actually, natural. Okay, सबसे अच्छा. What happens is when an image is formed, now see the eye has this kind of oval shape, and we have eyelashes here, ciliary muscles. Okay, very crude kind of diagram. We have retina here, which is a screen for the image. When an object is placed in front of eye, what happens is light rays from the extremities of object, they enter into the eye. Okay, light rays, they form this image. थोड़ा सा अच्छा कर देता हूँ इसको. Okay, so this is the image formed. Okay, now if the same object is placed closer, what happens is in this case this would be the image formed. Okay, so an object which is placed closer, it activates more number of retina cells. It activates more number of retina cells, and due to that we get a perception of bigger image. Okay, and that is how we get a perception of how large an object is. So you can see that actually it is this angle. For in initial arrangement this angle was smaller, in the second arrangement this angle increases. Okay, it is this angle which plays an important role. The larger this angle, the wider would be the image. Is it okay? The bigger would be the image formed on the retina. This angle, let's call it visual angle. This angle is called visual angle, or we may call it angular size. Or we may call it angular size. Now angular size for human eye is not very large. As you know, the human eye has very small aperture. The eye lens has very small aperture. So only the paraxial rays would enter. Is it okay? Very small aperture, and at least 25 centimeters should be the distance for an object to be placed. So this would have small aperture, and this angle would not be very large. Is it okay? Since this angle is not very large, we can directly calculate this visual angle theta naught as h upon, let's call it this distance as u. This is the visual angle. I'm not taking tan. Actually, this value would be tan theta. But by paraxial approximation, I can write it as theta naught is equal to h by mu. Tan theta naught is almost equal to this. Is it okay? Okay, so all the optical instruments which we study, they have this application of increasing the visual angle. More the visual angle, more would be the size of the image formed on retina. Okay, Is it okay? Okay. So what we'll do is every time we'll try to increase the visual angle. Let's see what is the visual angle for naked eye. When an object is placed at infinity, so u tends to become infinity. Okay. So for far away objects, u is infinity, and so visual angle will tend to 0. For now you know that eye has a power of adjustment, power of accommodation, but not it's not capable of accommodating the distances from 0 to infinity. Eye is able to is able to see the objects at infinity, but it is not able to see objects which are closer than 25 centimeter. I am talking of normal eye. Okay. So that normal, that the distance, let's call it capital D. Capital D is the distance uh, at which the image is just formed. It would be bigger in size, but it would be just formed. Any object which is placed closer to eye won't its image won't be formed clearly on the retina. Obviously, we will be able to see blurry image, but the clear image will be formed only if the object is placed at a distance at least d. Is it okay? This d distance, this point is called the near point, and d is called the least distance of distinct vision. Okay, let me call it near point distance. Okay, this is the near point distance. Okay, so for near point object or an object placed on the near point, u would be d, and theta naught would be what? H by d. So this is the maximum angular size. This is the maximum angular size which human eye can produce in a naked manner. Okay, without the help of any device. Maximum angular size for naked eye. Okay, as I said, we tend to increase this size. We tend to increase this angular size. Okay, the visual angle. So shall I continue? Correct? Continue. Now, first instrument is simple microscope और magnifier. ठीक है, मैग्नीफायर होता है जो हाथ में मोटा सा कॉन्वेक्स लेंस होता है, जो यूजुअली ऐसे आंख पे लगा के देखते रहते हैं, इन स्पाई टेलीविजन एंड ऑल, हैंड राइटिंग वगैरह चेक करते हैं, दैट काइंड ऑफ मैग्नीफायर. ओके, सिंपल मैग्नीफायर. अब हम इसकी बात कर रहे हैं. प्लीज ट्राई टू अंडरस्टैंड इट वेरी क्लियरली, बिकॉज मैं इसको रीयूज करने वाला हूँ फॉर फर्दर ऑब्जेक्ट्स. इज इट ओके? सो इट इज लाइक कि मैग्नीफायर के आगे हम लोग वी ट्राई टू पुट इन सम मोर थिंग, समथिंग एल्स, अनदर लेंस. ओके, तो मैग्नीफायर का जो भी फंक्शन होगा वो एज इट इज रहेगा. सिंपल मैग्नीफायर का हम यहाँ पे वो देखते हैं क्या होता है. लेट अस से दिस इज द ह्यूमन आई. आईलैशेस थोड़ी सी गड़बड़ हो गई. Okay, object, the nearest distance, the minimum distance at which object can be placed is d. उसके पास ले आओगे तो इमेज ही नहीं बनेगी. Is it okay? तो अब हम क्या करते हैं, हम मैग्नीफायर यहाँ रख देते हैं. This magnifier should have focal length smaller than d, otherwise कोई फायदा नहीं होगा. Is it okay? It should have small focal length, that means it should be a thick one. Okay, smaller focal length. What happens is, let me discuss two scenarios. Using a magnifier, we can produce an image. मैं यहाँ पे eye थोड़ा सा erase कर देता हूँ, so that हम लोग को ये सोचने की टेंशन ना हो कि eye कहाँ रखी जा रही है. Okay? हम दो तरह से यहाँ पे मैग्निफिकेशन कर सकते हैं, साइज इंक्रीज कर सकते हैं. पहला सिनेरियो इज when the object is placed at focal length, at focus of the magnifier. Okay, and since the focus is less than d, तो इस सिनेरियो में अब जरा देखते हैं क्या हो रहा होगा. एक ऐसे चली गई रे और एक ऐसे चली जाएगी इनफाइनाइट पे, है ना. द इमेज इज फॉर्म्ड एट इंफिनिटी. इज इट ओके? सो आई I'm placing the eye here. ठीक है, I'm placing the eye here. Eye captures these images. तो eye को these rays, eye को तो ये इमेज इंफिनिटी पे दिखने वाली है. Is it okay? eye को तो ये इमेज इंफिनिटी पे दिखने वाली है. अब to eye the visual angle would be this. Okay. What is the visual angle in this case? Theta dash is h by f, है ना. और नेकेड आई के लिए कितना था? थीटा नॉट होता था h by d. ये नेकेड आई के लिए था. Let's see angular magnification. या फिर विजुअल एंगल में इंक्रीज कितने टाइम्स हुआ? ये होगा व्हाट? थीटा डैश बाय थीटा नॉट. फाइनल एंगल बाय इनिशियल एंगल h by f upon h by d. This thing would be d by f. Is it okay? So since I said के ये कंडीशन होनी चाहिए ट्रू, we can see कि मैग्निफिकेशन एक से ज्यादा तो हो ही गया. तो एंड नॉर्मली हम लोग जो यहाँ मैग्नीफायर यूज करते हैं वो 10 सेंटीमीटर के आसपास के रेंज का होता था. एटलीस्ट 2.5 मैग्निफिकेशन तो हम लोग यहाँ अचीव कर ही रहे हैं. ओके, इन अनदर केस if the lens is moved closer, you know, आई को आप कहीं भी रख सकते थे यहाँ पे. विजुअल एंगल आई के लिए तो यही फील होने वाला था. ओके, अब यहाँ पे क्या होता है? बहुत दूर नहीं रखना है ऑब्वियसली. एक रे ये भी तो आ रही होती है ना. इज इट ओके? एक रे ये भी आ रही होती है, तो ऐसा कुछ होने वाला है. अब हम क्या कर रहे हैं? लेंस को वी आर मूविंग इट क्लोजर, स्लाइटली क्लोजर. ओके, सच दैट अब क्या होगा? फोकस यहां आ गया, ऑब्जेक्ट इज प्लेस्ड हियर. कंडीशन क्या हो गई कि u इज लेस देन f. u इज लेस देन f. ओके, इन दिस केस what do we get? Divergent rays. Okay, and they meet. ठीक है, ऐसा कुछ होगा. The visual angle would be this. Visual angle would be this theta dash, let's call it. What happens here is, अब theta dash की वैल्यूज कुछ भी हो सकती है. मैक्सिमम मिनिमम वैल्यू थीटा डैश की कब होती? जब इमेज इंफिनिटी पे होती. आपने इस लेंस को और थोड़ा पास किया तो अब इमेज इंफिनिटी पे नहीं बनेगी, अब तो थोड़ा पास बनेगी ना. कहीं कितना पास आप मैक्सिमम इमेज बना सकते हो सो दैट हमारी आंख को दिख जाए. आप मैक्सिमम डी डिस्टेंस तक, यहाँ क्या है? आई आपको बिल्कुल अटैच करके रखनी है विद द मैग्नीफायर, पास में बिल्कुल चिपका के. सो द मैक्सिमम डिस्टेंस at which image should be, the minimum distance at which image should be formed should be small d, should be capital D. अगर मैग्नीफायर और थोड़ा पास कर दिया ऑब्जेक्ट के तो इमेज ब्लर्ड हो जाएगी, तब नहीं दिखेगी. इज इट ओके? एंड यू कैन सी कि as the image is coming closer the visual angle is increasing. So in this case the visual angle would be maximum in size. Is it okay? Let's calculate the visual angle. Theta dash would be h by u. No, u, this time it would be u. This is h, the original size. Image has size hi. I'm not interested in hi. वैसे ठीक है. The image is formed at d. Okay, and we still know the theta naught is h by d for naked eye. ये सेम है. ठीक है, अब जरा देखते हैं इस लेंस के लिए. जरा लेंस फॉर्मूला लगाएंगे तो 1 by v minus 1 by u is 1 by f, है ना. v is on the negative side तो माइनस साइन, u is negative again तो 1 by minus d minus 1 by minus u is 1 by f. आप 1 by u कैलकुलेट करेंगे, होगा 1 by d plus 1 by f. ओके, लेट्स रिप्लेस. थीटा डैश कितना हुआ? h, इसको मैं h इंटू 1 बाय यू लिख सकता हूँ ना, सो h इंटू 1 बाय डी प्लस 1 बाय एफ, ठीक है। एंड मैग्निफिकेशन, एंगुलर मैग्निफिकेशन कितना होगा, थीटा डैश बाय थीटा, दिस इज h इंटू 1 बाय डी प्लस 1 बाय एफ अपॉन h by d, okay, so this d comes on the top और ये h कट गया, what happens is d अंदर multiply हो जाएगा with the numerators, so the first would become d by d, the second would become d by f, what we have achieved here is 1 plus d by f, okay, so एक से बढ़ा बस, लेकिन इस सिनेरियो में, इन दोनों सिनेरियो में फर्क क्या होगा, फर्स्ट सिनेरियो में image was formed at infinity, तो I was least strained, बिल्कुल जोर नहीं पड़ रहा था. In the second scenario, the eye would be maximum strained, okay, most strained हो गई, ठीक है, और हमने सिर्फ एक से इंक्रीज किया मैग्निफिकेशन, हो गया. Okay, rest we will continue in the next class. Time is up.
You can have a look. This PNC and I'm keeping vector L. Should we start? Okay. Good afternoon, girls. Today we are going to continue our vector class, right? So before I start my vector class, I wanted to recap whatever we did in the last time. So I remember, as we first discussed that there are two types of quantity. One we call it as a vector, and the other we call it as a scalar. And the vector has two properties, that it has magnitudes as well as directions, but the scalar has only magnitude. That is the word scalar comes from scale. Scaling, measurement, right? So scalar has only measurement, magnitude, and the vectors have direction as well as magnitude. Now after that we discuss what vector is actually, है ना? फिर उसके बाद we understood the notation that okay, if A B, then it means that we are going from A to B, then we can denote AB vector as AB, or rather make it as a vector, right? And after that we discussed that what do you mean by unit vector? Unit vector was nothing but the vector which has a magnitude of unit. And then then we discussed null vector. Null vector was nothing but a vector which has zero magnitude. After that we discuss what happens when a vector is multiplied by a scalar. When I say lambda a, it means I am multiplying my vector with a non-zero scalar, right? If lambda is positive, it means the magnitude is multiplied by lambda times, but the direction remains the same. And when the lambda is negative, direction reverses, but the magnitude multiplies by lambda times, right? And then we understood okay, we can also create a unit vector out of any vector by multiplying anything by 1 by mod a, because it's nothing but a lambda, it's a scalar. So 1 upon mod a into a gives me a unit vector with plus and minus sign, because we also understood the concept of parallel and anti-parallel, right? After that, we went to the algebra part of vector, that was addition of vectors. So the triangles law and the polygons law, which was solely based on the concept that vectors doesn't depend on the path you take. The vector finally talks about the initial point and the final point. And that is why we had this triangle law. Let's say if you are going from A to B and then B to C. So this is your vector A to B and this vector. It means this is AC. Right, and I can call that AC is equal to AB plus BC, right? This was your triangle law. Using the same concept, we also discussed the polygon law, that we are only interested in from the initial point to the final point. After that, we developed the concept of parallelogram law, because if we have two vectors, any two vectors will make some angle, right? Any two vectors will make some angle. I'm going to make these two as the adjacent of a parallelogram. If I make the adjacent, if these two as the adjacent of parallelogram, I can create a parallelogram out of it. And then we notice the interesting part about it, that the diagonals are plus minus of a plus b and plus minus of a minus b, right? That was what we discussed using the concept of triangle law, right? After the parallelogram law, what we discussed was that how can we represent our vector mathematically, right? That was the idea, how we are going to discuss, how we are going to represent our vector mathematically. Then we said that, okay, we need at least three directions. We need three directions to represent our vector in a mathematical way, right? So we chose three perpendicular directions. This was the three perpendicular directions, and we call it as x, y, and z. X, y, and z, right? After x, y, and z, we said that, okay, I have a vector 3D in 3D space, right? So what I tried to do, that I created a cuboid out of that. Then the lowest diagonal of that cuboid, or the body diagonal of that cuboid, becomes that vector. And then we learned that, okay, we can have a unique cuboid for every vectors, right? That was the story. After that, we understood, okay, fine, if I can represent my vector as a unique cuboid, then it has a length, it has a breadth, it has a height. So the length becomes the projection on x-axis, the breadth becomes the projection on y-axis, the height becomes the projection on z-axis. That was the story, right? After that, we understood that okay, my vector is making some angle with alpha, with x-axis as alpha, with y-axis as beta, and with z-axis as gamma. Then we understood that okay, cos alpha is the x component upon the mod. Then we similarly we got the cos beta part, and then similarly we got the cos gamma part, because these were nothing but the projections. The length, breadth, and heights were nothing but the projection of that body diagonal, right? And then we also learned that cos square alpha plus cos square beta plus cos square gamma is 1. We also understood what do you mean by projection on the plane. We did the question, the LMN question, which you remember it was an IIT question which we discussed last time, that the projection of a vector on xy plane is L, on yz plane is M, and on y and x and y and xz plane is N. So we can say that okay, if I say ai cap plus bj cap plus ck cap, I can say a square plus b square is m square, b square plus c square is m square, and a square plus c square is n square. So I can say okay, my magnitude is going to be L square plus n square plus n square by 2 under root. That was the IIT equation which we discussed. After that, we understood that it's not only that three direction needs to be perpendicular. They can be anything. They can be anything. So what we then we can uniquely draw a solid again, and that solid was called parallelopiped. And we also learned that parallelopiped, that cuboid is nothing but a parallelopiped only. And if we fix the length, breadth, and height or the edges of that parallelopiped, then the maximum volume will be contained by cuboid, right? That was the story, because we have fixed the length, breadth, and height. So it means that the maximum volume of a parallelopiped will be a cuboid, right? That was the story. After that, what we discussed was, can we go to the slides? After that, we discussed, after parallelopiped, we discussed the displacement vector, page number 11. We discussed the page number 11. Okay. Okay, this was page number 11. We, after discussing the parallelogram, we also discussed how to find the bisector of these two vectors, right? What was the concept which we used? We considered a parallelogram, a very special parallelogram called rhombus, because in rhombus, all the sides are equal, diagonals bisect each other, right? And diagonals are also perpendicular to each other, right? So this was the story, that the diagonals are going to be 90-degree, and the diagonals are also going to be the angle bisectors, right? So we can also find this way. Then we discussed the displacement vector. Okay, displacement vector was talking about, like, let's say we are moving from A to B, then A is a point and B is a point, then we are going to put a reference point as origin, then we are going to say we are going from A to B, then we can say that AB vector is nothing but B minus A, and B turns out to be the position vector of B, and A turns out to be the position vector of A, right, with respect to the origin. We also learned that we can move the origin anywhere, right? Then we discussed the section formula. You remember section formula, how it turned out to be the angle bisector thing. When we say a point is dividing anything internally, it means it's not the point, but it's the if I say this is M, this is N, this is ABC, then the angle bisectors D divides internally in the ratio M is to N, and the external bisectors divide in the ratio minus M is to N. That was the story. And we also learned the angle bisector theorem, how it turned out to be M is to N. That was in class 9, right? Okay. So we understand the section formula also. Internally, if I say C is dividing internally AB in the ratio M is to N, then I can say MB plus NA by M plus N. And externally it turns out to be minus N, and the position depends on which is, if I say M is greater than N, if I say M is greater than N, then my external bisector will lie here. If M is smaller, then it will lie there, right? That was the story. We learned that also. Okay, next page. We also discussed this question, right? We have already finished. I think everybody doesn't have any problem with this question. It was totally checking your section formula concept. Come down. And then we also derived centroid. Everybody understand what centroid? It's a point of medians, and then in center was angle bisectors, and we know how we created this using the section formula. Next, we also discussed orthocenter, and orthocenter what is nothing but a concurrent point of concurrency of altitudes, right? It was point of concurrency of altitudes, and we saw that we derived it using the concept we remember, right? The section formula only, and we derived various results. Please go back to the last class, and please, if you have forgotten, please make sure, because these are very important as far as coordinate geometry is concerned, as far as solution of triangle is concerned. So these are the things which you must not miss. Now, circumcenter, we already discussed the U-notch line, right? And U-notch line was nothing but it says that the centroid and the circumcenter and the orthocenter, they lie on the same line, and the centroid divides that line in the ratio 2:1. It's far from orthocenter, closer to circumcenter. Very good. Then we discussed, did we discuss the collinearity? I think we went till dot product. So when I talk about condition of collinearity, when I say this, I can see this point A, B, and C are collinear. When I say these 3 points are collinear, it means I can see they are all lying in the same line, right? It means this vector and this vector, AB vector and AC vector, they are parallel. So I can say AB is lambda AC, right? No. So I can say B minus A is lambda of C minus A. So I can say, I rearranged every equation, it turned out to be lambda minus 1A plus 1B minus lambda C, right? And if you add these all coefficients, what you're getting? 0. So that was a thing which we understood, that okay, if ABC are the position vectors of 3 points, and if they are collinear, it means their coefficients. If I say XA plus YB plus ZC is equal to 0, it means X plus Y plus Z is 0. Can we go to the next page? After that, we understood this thing. There was no issue till here. Can we come down? Then we understood, okay, fine, if we have 3 coplanar vectors, if we have 3 coplanar vectors, we can create a triangle out of it, right? That was the concept. So if these 3 vectors are not coplanar, let's say 2 vectors are coplanar and third one is protruding out, it means we cannot create a triangle. So that was the story. So I can say any 3 coplanar vectors can be summed up as a linear combination. That was the story, plus minus A, plus minus B, plus minus C. Of course, we have scaled it so that the triangle inequality doesn't get abused, right? Can we come down? Next page. So that was the result. We understood that when 3 vectors are coplanar, that is are parallel to a plane, we can any day create a. So actually, when we have to test whether 3 vectors are coplanar or not, it's simple that in a practical way, it means that we can create a triangle if we scale it properly, right? If you multiply it with some particular. So it means that if I will get the sum as 0. So we can write them as a linear combination, right? This was the story. If we are not able to write them in a linear combination, it means I am not able to create a triangle. And when I am not able to create a triangle, when it is out of the plane, it means 3 planes are not coplanar. So that's the condition. We understood that the condition of coplanar. Can we now? So that makes sense. We can say C is lambda A plus mu B. If vectors are coplanar, you can express one vector as a linear combination of other 2. If you are not able to write it, it means they are not coplanars. Can you go to the next page? So if A, B, and C are coplanar, then they are linearly independent. Now the question was find whether these 3 vectors are coplanar or not. We discussed it. We just wrote this is equal to lambda times this plus mu times this, and we have 3 equations and 2 variables. So 2 equations was used for finding lambda and mu, and we just checked whether the third equation is being satisfied or not. If it is satisfied, they are coplanar. If it is not satisfied, they are not coplanar. I think they were not satisfied, right? So these 3 were not coplanar. Now this question was if S and H was totally entirely or based on the concept of position vectors and Euler's line, right? We made S as our origin. Then this turned out to be 3 times of centroid. This position turns out to be 3 times of, and which finally made us that okay, it's in the same direction from the position. If you see, if I call this as X, this was G, and this was H, and we understood our question was thrice of SG. Thrice of SG. If I call this as X, this was 2X. So what is the thrice of this? This one. So it turned out to be that it is SH, right? And this was totally talking about the concept of uh, uh, section formula only, because these 4 points are coplanar, so they must 2 points. If I take any 2 points, and I'll make, they will surely be cutting at some point, right? That was the concept we used, that 2a plus 5c is equal to 3b minus lambda d. And then we found out that okay, we can divide both sides by 7. It means that they are on the coplane. It means lambda is minus 4. That was the story. Lambda turned out to be 3 minus lambda turned out to be 7, so lambda turned out to be minus 4, right? Lambda turned out to be minus 4, so we understood, okay, they are breaking in the ratio, and then we actually found out, right? There is no issue till here. Can you go to the next slide? Now, this was the story from where we will start again. Now, we are going to talk about dot product. Dot product, when we talk about dot product, we say that, let's say this is your vector, and this is your other vector. Let's say this is your B vector, and let's say this is your A vector, right? And if it is making theta, I can say A dot B is equal to mod A mod B cos theta. Okay. Now, dot product is one of the product which actually helps us in finding the angle between two vectors. Why? Because cos is the best indicator between acute and obtuse, right? Because for acute it is positive, for obtuse it is negative. Very good. So I see that this turns out to be this. Then I can actually create this projection of this on this. So this turned out to be a projection vector. We call it a projection vector or orthogonal vector. So I can say this is nothing but mod B cos theta. I can call this length as mod B cos theta, and I know the direction. It will be A by mod A. Okay. Now I can replace my mod B cos theta as A dot B upon mod A. So I can say the orthogonal projection turned out to be this is your orthogonal projection or the orthogonal vector. We call it orthogonal projection of either we call it orthogonal vector or we call it a projection vector. Understood? Orthogonal vector or projection vector. So you understood what is the length? Mod B cos theta. Clear? Can we go to the next slide? Can we come down? Okay. So we understood that okay, mod A dot B is mod A into mod B cos theta, which means the angle between them is theta. When I say I dot I, these are the unit vector in the direction of positive x-axis. What is the angle between them? 0. What is cos 0? 1. So I can say, right? No issue till here. And then we also discussed that I dot j is equal to 0 and j dot k is also 0 and I dot k is also 0, right? Then we also discussed the 3 laws of product, that was associative law, distributive law, commutative law, and we just checked whether which of them works fine for dot product. We understood that the associative law turns out to be a meaningless thing, because when I say A dot B dot C, it means B dot C is a scalar quantity. I cannot take a scalar with a vector dot, because dot they must be talking about the angle. It doesn't have any direction, so how can I find the angle? So it's a meaningless thing to say that A dot lambda. Okay. Then the next thing was commutative law. Commutative law was like A dot B is equal to B dot A. Is it equal? Yes, we found that. Okay, fine, there's no issue. If I say A dot B and B dot A, they are same, right? So we can say, okay, the dot product follows the associative law. Now, distributive, we saw that okay, when I say A dot B plus minus C, I can go ahead with it, right? A dot B plus minus A dot C, right? You can also prove it through anything of algebra you want to prove it, right? Then after that, we understood that if I say A is x1 I cap plus y1 j cap plus z1 k cap, and B is x2 I cap plus y2 j cap plus z2 k cap, right? So I can say A dot B is x1 x2 plus y1 y2 plus Z1, Z2. Okay, and you know how to find, if I have to find an angle between two vectors, I can any day say cos theta is equal to A dot B upon mod A mod B. Always remember, whenever you are talking, even if we are solving the question of coordinate geometry, if the person wants to know about the angle, think of dot. Think of dot product, right? We have discussed last time when the condition of any theta angle of a triangle turns out to be a acute angle or obtuse angle, right? Okay, we have already discussed this projection of B on A. Can we go to the next slide? We have already discussed also known as orthogonal projection. Okay, now this is one of the most important inequality of which we get through dot product, and that is called Cauchy's inequality. Let's see what is it. When I say A dot B, when I say A dot B, it means mod A mod B cos theta. Understood? What is the maximum value of cos theta? 1. It can never be greater than 1. If I square it up, this will be mod A square mod B square cos square theta. Clear? It will always be lesser than or equal to. Understood or not understood? Okay. So if I say vector A can be anything like x1 I cap plus y1 j cap plus z1 k cap, right? What is x1, y1 and z1, by the way? They are real numbers. They are scalars, right? Any three real numbers. It can be any three real numbers, right? It can be 0, it can be positive, it can be irrational, it can be irrational, anything, but it will be a real numbers. Now if we say B as x2 I cap plus y2 j cap plus z2 k cap, this is also going to be any three real numbers, right? So when I say A dot B, it will finally be x1, x2 right? This is going to be my left hand side. It will be less than or equal to. I'm skipping this equality sign. I'm coming directly to this. What is mod A? Under this square plus this square plus this square, and square of this will be mod A square. So I can say x1 square plus y1 square z1 square into this inequality is true for any. This inequality is true for any six real numbers. Any six real numbers. You understand? We are not talking now vector. We are talking about simple algebra of numbers. That if I say these six are any real numbers, then this, the product of these two plus product of any two real numbers plus product of any two real numbers ka square will be less than the squares of this plus this plus this into the squares of this plus this plus this. Now you know the root from where it is coming. It is coming from the simple concept of A dot B. We call this inequality as Cauchy's inequality. This is called Cauchy's inequality. So isn't it good that, okay, fine, for any six real numbers we can say that this inequality holds true. Anybody wants proof, you can go ahead with the proof, right? Now my question is, when the equality holds true? Is the inequality true for any real numbers? And my question is, when this equation is true, x1 x2 plus y1 y2 plus z1 z2 ka square is equal to x1 square plus y1 square plus z1 square into x2 square plus y2 square plus z2 square. हाँ, कब होता है equal? When theta is 0 means this x1 x2 plus cos inequality कब true होगा? जब these two are parallel. When are they going to be parallel? वो तो हो गया. What is the condition going to be? Number sum. Because we are not going to answer in the terms of, okay, fine, you have understood that, okay, these x1, you have understood that these two vectors are parallel, but are you going to say that these two vectors are parallel? I cannot see any vector in this equation. How can you say that these two vectors are parallel? You have to say in the number language, you have to decrypt your answer from the vector form to the real number form. So you can say that A and B, even knowing you are going to say that A and B are parallel vectors. And when I can say A and B are parallel vectors, when I say A is equal to lambda B, so I can say x1 by x2 is equal to y1 by y2 is equal to z1 by z2. This is going to be my answer. Getting the idea or not? So here I say that theta is zero. Where can I see theta here? I see only 6 real numbers. So the answer is going to be x1 by x2 is equal to y1 by y2 is equal to z1 by z2, right? Okay, this is Cauchy's inequality. This was, so you were talking about vectors and suddenly you jump to the 6 real number story, right? This was the story. So can we go to the next page? Okay, now tell me, when I say A dot A, it means mod A square, right? x1 square, right? So I can also say mod A square is equal to mod A square. Okay, I can say that vector A square is mod A square, right? When I say vector square, I'm talking about dot product. Clear? So I can also say that A plus B ka whole square, I can say it or not? I can say it, no? And what is this going to be? A dot B. Clear or not clear? Similarly, I can also handle this with minus. Understood? Okay. Now, what about this? I can say mod A square, mod B square, mod C square plus twice of A dot B. Clear? This is a story which you were taught in class 9. That A plus B plus C ka whole square is A square plus B square plus C square plus 2AB plus 2BC plus 2C, right? Can we go to the next, last page? Down page? Okay. Now, here everything is making sense. Like A dot A is making sense, this is making sense, this is making sense, this is making sense. So it means when I say I have to multiply A plus B dot A minus B, I can say A square minus B square, right? Because A dot B will cancel out. So see, everything is same. Everything is same. No problem till here. So dot product turned out to be a very easy thing, right? Can you go to the next slide? Okay, now the question comes. If mod A is equal to mod B is equal to mod A plus B is equal to 1. They all are unit vector. Find mod A minus B. How to go for it? We already learned that mod A plus B square is mod A square plus mod B square plus 2A dot B. And we also learned that mod A minus B square is minus 2AB. So if I add this square plus this square, I will get what in the right side? Twice of mod A square plus. So find out. It's very easy now. Root 3, perfect. Understood? Because on the right hand side, mod A square is 1 and mod B square is 1. So 1 plus 1 is 2 and that will double itself because we have 2 mod A square plus 2 mod B square. So on the right hand side I got 4. On the left hand side I get mod A plus B square plus mod A minus B square. I have to find mod A minus B square. So mod A plus B square will be 1. So 4 minus 1 is 3. So mod A minus B square is 3. So mod A minus B turns out to be root 3. Perfect. Yeah, the next question is an IIT JEE question. If mod A, B, if A, B, C are unit vectors, then the maximum value of mod A minus B k square plus mod B minus C square plus mod C minus A square. First, we must expand it. Please open it up and see what's turning out to be. Why 4? What made you think that it's 4? See, I'm just going to expand it up. It will be mod A square plus mod B square minus 2A dot B, right? Same thing will be plus mod B square plus mod C square minus 2B dot C plus mod C square plus mod A square minus 2A dot C. I know this thing, this constant, and it will turn out to be 6. तो 4 कैसे आ गया था? 6 minus 2 of A dot B plus dot C plus A dot C. So you said that, okay, this is 1. Why? Why it will be 1? See, I have to maximize this, right? I have to maximize this expression. Where did we see this expression? Where did we see this? A plus B plus C का whole square, right? So do that. A plus B plus C का whole square will turn out to be mod A square plus mod B square plus mod C square plus this. Okay, 6 minus cloud. Okay, I have to maximize 6 minus cloud, right? What is mod A square plus mod B square plus mod C square? 3. 3 plus cloud. Okay, it will always be greater or equal to 0. Understood? Because it's a positive quantity. Okay, so cloud will always be greater than. If I multiply minus on the both side, what happens to the inequality? Reverses. So I can say minus cloud. If I add the same quantity on the both sides, inequality remains the same. So the answer is going to be 9. It was an IIT question, okay? So it's very easy question, right? Let me go to the next question. I plus A is equal to I plus G plus K and B is G minus 2K. I think most of the questions which I have put is from IIT JEE. So don't think कि आप IIT JEE questions नहीं कर पा रहे हैं. You are able to handle it. So if I say A is equal to I plus J plus K and B is J minus 2K, find a vector of length 6, of course, which is in the plane of A and B and perpendicular to A. I can find 2 ways to solve this question. See, 2 ways. First, तो चलो diagram ही बना लेते हैं. Let's see the diagram way. If I say this is y, I want the vector to be perpendicular to A. So I'm going to say this is my vector A. Okay. And B will make some angle with A. So I'm going to call this as B. Okay. This is my x vector, which follows the same condition. That my x vector is coplanar with A and B, right, and perpendicular to A. So I can say my x vector, I know this is my orthogonal projection OP. What is the orthogonal projection is? A dot B upon mod A square A. This is your orthogonal projection. So I can, using the concept of triangle law, I can say this plus this is this. this plus this is this, so this is equal to this minus this. So I can say x vector is so this is going to be a vector जो मेरे interest का है, right? This is the vector of my interest. So my जो C vector है, which is going to which the final vector which I have to find as an answer, उसका magnitude क्या होना चाहिए? 6 होना चाहिए. इसका magnitude हम निकाल सकते हैं. So I can say x cap is going to be plus minus b minus a dot b upon mod a square a. Of course, it will all simplify if you put the values, right? Upon mod of this cloud. Right, this is the way we find the unit vector. The vector upon the mod. So finally, my resultant vector is going to be plus minus 6 of this cloud. Get the idea? This whole thing. What is mod cloud? Mod of x. Okay, it's not going to be this difficult because if you are going to put a dot b turns out to be a normal scalar, right? And then mod a also turns out to be root 3. So it can all short down to a very linear vectors, right? It won't look this ugly. But I just showed you the method. Right? And then don't forget to put plus minus because he's not telling you which direction. Both are fine. It can be this way also. Right? In the same plane with A and B and perpendicular to A. Right? So I just put plus and minus. Clear or not clear? Very good. So now I have next theorem. We call it Apollonium theorem. For आपने पढ़ा होगा ये theorem? Very good. So you have a triangle and then you draw a median. आपने class 10th में proof किया होगा, I am sure. You have a triangle ABC and then D is the midpoint of BC, means AD is your median. AD is your median. Now the question is you have to prove that AB square plus AC square is equal to twice of AD square plus BD square. So this is the theorem, Apollonian theorem, and we have to prove this. I'll just observe on the left hand side. On the left hand side, what I see is AB. This is my AB vector, right? This is my. So I can say AB vector is nothing but AD plus DB is equal to, clear or not clear? Clear. On the left hand side, again see the another vector which is AC. So I can say AC vector is AD plus is equal to AC. On the right side, I find AD and BD. So I want my things to be written in BD form. So DB can be written as minus and DC can be written as plus BD because DC and BD they are of the same magnitude and the same direction, right? So I know if I square it up, this square plus this square plus this square plus this square minus वाला खत्म हो जाएगा is equal to this. Hence proved. Clear? Square this up, square this up, square this up, square this up, add and get this. Clear? कभी नहीं भूलोगे आप, बहुत ही आसान था. Clear? Now the next question is find the angle between the body diagonals of a cube. What is a cube? A cuboid whose all edges are equal, right? And when I say body diagonal, it means the longest diagonal I am talking about. So let's first draw a cube. Let's say this is my cube of 1 unit age. This is my y axis, this is my x axis, and this is my z axis. Now I can say this is my origin, which is O, 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 and this is my opposite, which is 1, 1, 1. So I can say one diagonal as I cap. So one body diagonal is going to be, what's other body diagonal can be? Yahan se yahan, right? What is this point is going to be? And what is this point going to be? It's on the YZ plane. Clear? So what I can say about the vector, this other body diagonal, it can be minus I plus J, right? This is the story. When we have to find the vector, we have to think of dot product. Dot product, so I can say dot of this minus 1 plus 1 plus 1 upon the mod is equal to cos theta 1 by 3 is equal to, so theta turns out to be, this is the angle between two body diagonals, right? अगर -1/3 भी आ जाएगा तो कोई फर्क नहीं पड़ता, एक acute है तो एक obtuse obviously होगा. Clear? Understood or not understood? Okay, can we go to the next question? Down, 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 down. Okay, it's already the down. Now this one, if P, Q are vectors such that my P vector is perpendicular to Q plus R and Q vector is perpendicular to R plus P and R vector is perpendicular to P plus Q. What can we say about P, Q, R? They are mutually perpendicular to each other, right? These three vectors P, Q, R are mutually perpendicular to. Can we say this? Very good. Can we go to the next page? Now the question comes. A dot P upon mod P square P plus A dot Q by mod Q square Q plus A dot R by mod R square R is equal to. Have you seen this expression? What is this expression? Orthogonal projection. You have put orthogonal projection on three axes, P, Q, R. So it's basically you're writing your vector mathematically in the form of three mutually perpendicular vectors. So it's going to be finally A vector. Understood or not understood? Understood? What's the idea? If I say, can you go up. What's the idea? It's the idea like if this is your P, this is your Q, and this is your R. And we have already learned that it's not necessary that we have to write our vectors always in the form of ijk. We can write it in the form of any three. It doesn't matter even if they are perpendicular or not. But in this case, they are perpendicular. So we are actually creating a cuboid. So the cuboid's projection is going to be that. Clear? Now, this was the story of dot product. So you understood the dot product, how it's working. We also understood the Cauchy inequality using the dot product, right? We also understood the orthogonal projections. We also understood that for finding the angles, we should always fall back for the dot product, right? Now come to the cross product. We'll follow the same drill of cross product. We'll try to understand what actually is cross product. When I say we have two vectors, they must be making some angle. So they are making, let's say, A and B, and they are making angle theta. So I can say A cross B is but it's not going to be a vector quantity, it's not going to be a scalar quantity, but it's going to be a vector quantity. We call it a vector product. When I say A cross B, where is my finger pointing out? We always follow, for finding out the direction, we always follow the right hand rule. So if I am going anti-clock, my thing is going out, so the normal vector is going to be out. When I am going from B crossing, I'm going n. So I'm going to call this as n vector. And you know how to find n. N is simply a vector perpendicular to A and B and which follows the right hand system. When I say right hand system, I'm talking about my right hand. You're going to curl your fingers on the directions from where to where you're moving. The fingers are going to, if you have you ever noticed when you are screwing the thing, अगर वो right handed threaded होता है, mostly ज़्यादातर we have the right handed threaded system everything. But when you are tightening it, आप कैसे करते हो टाइट? Clock or anti-clock? Clock. You do it clockwise. That's why you see right here, it's clock. It's going in because that system is right-handed system. When you have to actually loosen everything, what do you do? Anti-clock. Don't be surprised if you get something like in opposite thing. That's nothing but the threading is done in a left-hand system. Okay, when you will be studying gears and mechanical engineering, you'll be able to understand more about the right-hand threading system and left-hand threading system, right? When you see a screw, when they say it's a right-hand system, they write it plus. And when you have a left-hand system, they write it minus. So when you are in, क्योंकि some instruments are so delicate कि आप हल्का सा भी गलत direction move करोगे तो वो instrument खराब हो जाएगा. So for that, they पहले ही से क्योंकि आप क्या होता है आप जाते के साथ पैकेट लगाते हो, right? तो आप और ज़्यादा टाइटन कर देते हो. ओवर टाइटन भी नहीं करना होता है, अंडर टाइटन भी नहीं करना होता है, right? So they show you the symbol of plus and minus. So if they say plus, it's a right-hand system. You're going to follow this. If they say minus, they talks about the left-hand system, right? So everything is mathematics. You see. Now we are going to see the three laws which we discuss in the cross also, dot product also. So first law we are going to talk about is associative law. Whether we are going to see whether associative law is followed by cross or not. When I say A cross B cross C, और इसका associative part होगा A cross B cross C. In general, they are not equal. We'll see why. We'll see in this study. We will see why. So in general, but there must be a condition यहाँ पे equal होगा. So in general, we write it. They are not equal. So in general, it doesn't follow the associative law. We'll find out when it follows the associative law. Okay. The second thing is A cross A and B cross A. That is commutative law. They are not equal, but if I put minus sign, they are equal. Understood? Magnitude wise, they are equal, but direction they have opposite. Of course, I see the clock, B cross clock, I am going in. When I am A cross B, I am going anti-clock, I am out. Right? This is the story, so the direction is opposite. Clear? Distributive law, yes, it follows is distributive. So the cross product is only follows distributive law. Okay, A cross B plus minus A cross C. That is the distributive law. So out of these three laws, which law is hold true for a cross? The distributive. And for dot, it was not just associative was not holding true, but commutative and distributive were holding true. For this, associative in general doesn't hold true. We'll see when it holds true. In commutative, with a minus sign, it follows, and in distributive, it follows truly. Right? Can we go to the next slide? Okay. Now, if I say if vector A is parallel to vector B, it means A and parallel to A. So it means A cross another vector B which are parallel is mod A, mod B, sin 0 or sin 180. What is sin 0 or sin 180? Sin 0 or sin 180? 0. So finally, when I say if A and B are parallel, their cross product is going to be 0, right? So in the same way, we can say I cross I, J cross J, K cross K. They all will turn out to be. So I cross I, J cross J, K cross K, the cross product of parallel vectors are going to be 0. Now, since we all are following right hand rule, I cross J, x axis, y axis gives me positive z axis. J cross K and K cross I. See, it's following the same. ये cycle follow कर रहा है. I J K. हमेशा ये cycle follow करेगा. Again, it will start I J K. Clear? I cross J gives you k, j cross k gives you I, k cross I gives you j. हल्का सा भी चेंज किया आपने ऑर्डर, reverses, right? Sign reverses. Ij gives me k, jk gives me I, and ki gives me j. If I say ik, it is minus j. Clear? Now, when I say A is x1 I cap plus y1 j cap plus z1 k cap, and B is x2 I cap plus y2 j cap plus z2 k cap. So, A cross B is given by I, j, k, x1, y1, z1, x2, y2, z2, which you can easily prove it, right? But it's very easy to keep in mind, because if you solve this, it will turn out to be I iota y1 z2 minus y2 z1 minus j x1 z2 minus x2 z1 k x1 y2 minus x2 y1, right? If you do the tidy way of multiplication, this will turn out to be 0 and ये इसके साथ k बनाएगा और इसके साथ minus j बनाएगा, इसके साथ ये माइनस के बनाएगा और इसके साथ 0 और इसके साथ प्लस I, इसके साथ ये. So you can actually follow that, right? But finally it will turn out to be this matrix, right? So this is structure you will get, right? Now the question is, what is the geometrical interpretation of this thing? When I say, see, dot product was talking about the angle. Now what this geometrically talking about? Let's see what this geometrically talking about. When I say A cross B, when I say A cross B, it means mod A, mod B sine theta, right? And it will be some root vector which is normal to those root 2 following the right hand system. Now let's say this is my A and this is my B, right? So I can create a parallelogram, right? I want to find the area of this parallelogram. So base into height is the formula. This is mod B sine theta and this is mod A. So area is going to be mod A mod B. What is the magnitude going to be? यही होगा ना? So we understood that my vector product of A cross B means I am just finding the area of the parallelogram with sides A and B, and the direction gives us the vector area direction. So basically when you have to find area, it will be, you are not interested whether it is going in or going out, right? But you have to find a vector area, you should tell me the normal thing. Let's say if I have to find the area, the vector area is going to become out. If I have to find vector area this way, go in, right? You get the idea? Surface से बाहर आता हुआ जो part होता है, that is the vector area. Magnitude wise, yes, it is a cross product. So cross product geometry gives us the area of parallelogram. Clear or not clear? Can we go to the next slide? So area of triangle, obviously, if I have to find a triangle area, let's say this is my triangle, let's say A, B, C. Okay. Now, मैं कभी भी पैरेललोग्राम बना सकता था इससे, आपको भी पता है एरिया ऑफ ट्रायंगल इज हाफ बेस हाइट, सो आई कैन से हाफ ए क्रॉस सी, या कोई भी दो मैं वेक्टर ले लूंगा, उसके बीच का एंगल हाफ दैट क्रॉस. क्लियर और नॉट क्लियर? Clear. If I am going to take A cross C, I am getting a positive area. If I am going to take C cross A, negative area. So when you are not interested in the, because area is something which needs to be magnitude. Always we need in the magnitude, right? So can we solve this question? Find the area of a triangle for these 3 points. We have 3 points, 2, 1, minus 1, 3, minus 2, 2, minus 1, 0, 3. Find the area of triangle formed by these 3 points. First, draw the diagram. Take any two sides, write the vector, and then take half of that cross product. And then you're only interested in the magnitude. आपको याद होगा कोऑर्डिनेट ज्योमेट्री में भी आप एरिया निकालते थे, है ना? That was very easy, right? So I can say, let's say this is going to be 2, 1, minus 1, 3, minus 2, 2, minus 1, 0, 3. So let's say these two vectors I'm choosing. I could have chosen any pair, but I just chose this. So this vector is going to be minus 1 minus 3 is minus 4 I cap, 0 minus minus 2 is 2 j cap, plus 3 minus 2 is k cap. Clear? And this can be written as minus I cap plus 3 j cap minus 3 k cap. Clear? So the area turns out to be half I j k. Take this one first, minus 4, 2, 1. Take other one as minus 1, 3, minus 3. Solving this, you will get the area. Right? Or not? Correct? Understood? Now the next question turns out to be, prove that area of quadrilateral ABCD is half of AC cross BD, where AC and BD are diagonals. Prove it. How to prove? First draw the diagram. Draw the diagram. I see that my triangle, I just take one diagonal, and I can say that my triangle is split into two triangles, right? Isn't it? So I can say half BC cross AB, half BC cross AB, and half DA cross, this is going to be the DA cross DC. Okay. कौन सा? I've taken this triangle like AB cross AD. Okay. There also it can be fine, no issue with that. Simple say, let's say if I call this as AB and this as AD. So I can say this triangle as half AB cross AD, right? And the other way, other thing will turn out to be half, let's say this, so half BC cross BD. You can say this now. BC cross BD. This is one triangle. The other triangle is this. So half BC cross BD. Now tell me this AB plus AD turns out to be BD, right? Half AB plus AD turns out to be BD. So I can say that I need to remove AB from here. So I can say AB, I want my answer in AC and BD, right? So AB can be written as, this AB can be written as DB minus DA cross AD. Wait, we have to draw again the diagram. All has gone hodgepodge a little. We'll start from the very beginning. If I see this, A, B, C, and D, I'm going to split this. So I can say half AB cross AD, right? Plus, I'm going to split this way, half CD cross CB. Clear? I can say this. Now, I want my AB AD plus BD is equal to AD, right? AD plus BD. AD plus BD is AD. So I can write half AB cross AD can be written as plus half CD cross CD can be written as CD can be written as BD minus BC. BD minus BC cross CB. Right. अब देखो क्या हुआ. Half AB cross AB will turn out to be cancelled out and we'll be left with half AB into BD plus CBBC will get cancelled and we'll left with. Now what you see the common thing BD, but you have यहाँ पे पहले यहाँ पे बाद में, so I can say minus CB BD. So I will just apply the AB minus CB is equal to cross. And what is AB minus CB? CB. This is your AB and this is your CB. If I say minus CB, it means this way. AC बन जाएगा. So finally you will get half AC cross BD. Clear? I just split my triangle in two parts, half AB cross AD, and then the other part was half CD cross CB. Then my answer should have only diagonals. I'm not interested on the sides. So what I did, I just replaced AD by AB plus BD, and then I replaced CD as BD minus BC. So I got this thing, and then we actually simply did the vector addition. Right? Any problem till here? No. So for any quadrilateral, if they have given, you need to find the area by cross multiplying the diagonals into half. Clear? Can you do the next question? The question is A is this and A cross B is this and A dot B is this. Find B. How to find this? I see A is I plus 2j minus 2k. So A is given and A cross B is given. So I'm going to, and I have to find B. So I can say my B is xi cap yj cap plus zk cap. So A dot B turns out to be x will be equal to 3. First equation. क्रॉस के लिए क्या करेंगे A क्रॉस B. So I J K नहीं A है ना तो A will be 1 2 2 minus 2 and X Y Z. So I can say I is equal to 2Z plus 2Y minus J Z plus K no plus K alternate plus minus ठीक है Y minus is equal to 2I minus 2J minus K. So 2Z plus 2Y is 2, minus of Z plus 2Z is equal to minus 2 and Y minus 2X is equal to minus 1. You have three equations. We have the fourth equation as well. Clear? No issue till here? Actually, this is not the three equations. This will turn out to be only two equations. How? Let's see. If I say Z plus Y twice, that is 1. First equation. B. Then I say Z plus 2X is equal to 2. Y minus 2X is equal to. Actually, D is not a new equation. Why? If you subtract B minus C, you will get D. So it looks that you have 4 equations, but actually you have, and then you can find, right? बहुत सारे लोगों को लगा कि डॉट प्रोडक्ट देने की जरूरत नहीं थी. We can create 3 equations here, but actually we are not creating 3 equations. We are creating 2 equations because the third equation is as a result of the difference of first 2 equations, which you could have easily got it, right? So this is actually not the equation, no equation. It's simply so these 3 are not sufficient enough to solve your x, y, z. You need this also. So now you have actually 3 equations. And how many variables? 3 variables, right? No issue till here. Now the last question. Any idea? Anyone flashing with any idea? A plus 2B plus 3C is equal to 0. It means that A, 2B and 3C are they are quite understood. Very good. But what's the, see the question? Question talks about A cross B plus B cross C plus C cross A is equal to X into A cross B is equal to Y into B cross C and Z is equal to C cross A. You have to find X, Y, Z because X, Y, Z are simply a scalar, right? So how to go for it? Any idea? You see, it's यहाँ पे दे रहा है कि they are A cross B plus B cross C plus C cross A in terms of A cross B. They have written the whole story in terms of A cross B, and then again they have written the whole story in terms of and then again they wrote this to C cross A terms. So it means we have to play with this, and we have to find this in terms of A cross B. We have to find this in terms of A cross B, so that we can get X. Similarly, we have to find this in terms of B cross C, this in terms of B cross C to get Y. Then we have to find this in terms of C cross A, this in terms of C cross A. It's already in C cross A to get Z. How to go for it? See, the only equation which will help me is A plus 2B plus 3C is equal to 0. If I take cross, if I take the whole thing with a cross, let's say C, if I'm going to take everything with a cross C, I can take 0 cross C is equal to 0. Equation में कोई problem नहीं आएगा. So I can say A cross C plus 2 B cross C plus 0 is equal to 0, क्योंकि C cross C 0 होता है. So I can say A cross C, एक तो आ गया ये कंडीशन हमारे पास, क्योंकि I can write A cross C in terms of B cross C, or rather I can write C cross A in terms of B cross C. Clear? Now the same thing, ऐसे ही हम तीन relations create कर सकते हैं. I'll take now the cross with B, so I can say A cross B plus 3 C cross B is equal to 0. The second thing. And the third relation I can derive by taking the cross with A. So A cross A turns out to be 0. So 2B cross A plus 3C cross A. Now I have to write my left hand side, the first thing, the first left hand side in terms of first A cross B. So A cross B will remain A cross B plus B cross C, where I can see B cross C, here I can see B cross C. So if I put this thing here, this will become 3B cross C, right? Because minus will take care of C cross B part. So I can say my B cross C is A cross B by 3. And then I have to write C cross A. So A cross C is, we are going to say, okay, I can say C cross A, hai na? Okay, so I can say 3C cross A is minus 2B cross A, which means 2A cross B. So I can say 2 by 3. Understood or not understood? Because this is 3C cross A, I have to find C cross A only. So it will be minus 2B cross A, that will become 2A cross B. So 2 by 3A cross B. If I add it up, I'll get 2 of. So X turns out to be. Similarly, I can find Y also. Y के लिए क्या करें? I want everything in B cross C form. So A cross B already in the form of. So 1 by 3 A cross B can be written as 3B cross C plus B cross C, and then C cross A minus C cross A is minus 2B cross C. So it will be 2. So it will finally turn out to be 5 हो गया ना? 6. Clear? And similarly, the third part is I want A cross B in terms of C cross A. So I can say A cross B is equal to 3 by 2 A cross C, है ना? ये इधर चला जाएगा तो 3 A cross C हो जाएगा. So तो माइनस वाला आएगा. Let me see. I want to change everything. So it will be 2A cross B, 3C cross A. Okay, so A cross B will be 3 by 2 C cross A. So 3 by 2 plus B cross C कहाँ है? यहाँ है. So ये इधर चला जाएगा. Minus A cross C. Finally it will be C cross A by 2 plus 1. So it will be 3. So 263 is going to be your answer, right? Clear? Next question. Now, since we discussed already that if 3, we can represent our vector in 3 unique direction, 3 non-coplanar directions. They are need not to be perpendicular. If they are not perpendicular, they will create a solid which we call it parallelopiped. Now I have to find, let's say I have to find the volume of this parallelopipe. You see this is a parallelopipe here. So this is your A, B and C, 3 non-coplanar vectors and they are not perpendicular. So they are creating this solid and we call this solid as parallelopiped. Now what is the volume of any parallelopipe going to be? The base area dot the height. ये होता है ना, base area dot height. So I am going to say the volume of parallelopipe is this. We call it scalar triple product, but symbolically we write it. We'll see what does it mean actually. So we are going to say square bracket A, B, C. So this means it's talking about, it's basically a scalar quantity. So it is talking about the volume of the parallelopipe whose edges are A, B and C. Okay, but what does it mean and from where it came? So can it come down? No. So when I say the volume is 0, when I say that all the 3 edges, they are creating a solid whose volume is 0, it means they are not creating a solid. And when these 3 cannot create a solid, when they are in the same plane, when they are in the, हमने एक और सीखा था, जब सेम प्लेन पे होता है तो एक बंदा दूसरे को लीनियर कॉम्बिनेशन में लिख सकते हैं. दूसरा चीज हमने क्या सीखा कि उसका स्केलर ट्रिपल प्रोडक्ट 0 होगा, means the volume of the parallelopipe will finally turn out to be 0 if these 3 are coplanar. So I just got 2 ways of finding the coplanarity of 3 vectors. One is if I am successfully able to write one of the vector as a linear combination of other 2 vectors, it means these 3 vectors are coplanar. Or if I am able to say that the parallelopipe created by these 3 vectors has volume 0, means we are not able to create the parallelopipe. It means that these 3 vectors are also coplanar. Can we come down? Okay, next page. So we have now the 2 methods to check the coplanarity. Okay, we'll find out later कि कैसे volume निकालते हैं. Come down. So basically I have shown you a pyramid. What is a pyramid? Which has a base and the sides are converging to an apex. Everything converging to the apex. The best example is the cone. The cone starts with a circular plate, then starts reducing circular हर क्या होता है, circular cone कैसे create होता है, एक circular plate फिर एक और circular plate, लेकिन उसका radius हल्का कम हल्का कम हल्का कम हल्का कम. So you are actually arranging the circular plates which is decreasing in radius linearly, that is why we get cone. If the radius is decreasing at a 2 degree, what will you get? Sphere. If you are arranging hemisphere, if you are arranging a circular plates, let's say, and you are decreasing, let's say if you are arranging a circular plates, आप उसका radius नहीं decrease कर रहे हो, 1, then 2, then 3, then 4, what are you getting? Cylinder, right? Now you are decreasing the radius linearly, मतलब बहुत हल्के हल्के, just जैसे एक कदम आगे बढ़े तो आप एक कदम radius करके घटाए. It calls a linear. So we get a cone, and when we are cutting it in a 2 degree, in a circle is a 2 degree equation. So we are decreasing the radius in 2 degree way, quadratically हम लोग decrease कर रहे हैं, तो क्या बन जाता है वो? Hemisphere. All the 3 are actually created by putting up the circular plates only. See what happened? जब हमने कोई radius change नहीं किया, तो it turned out to be a cylinder. जब हमने radius भले हल्के हल्के linearly change किया, it turned out to be cone. And then जब हमने क्या कहते हैं किया, तो it turned out to be hemisphere. वो कुम्हार लोग नहीं काम करते रहते हैं. So when they want the shape, accordingly ऐसे create करते हैं ना कि कैसे change करना है कितने rate से. That's why they create beautiful shapes, right? So it's basically they are running the equipment in particular rate. अगर आप linearly बढ़ रहे हो तो it will turn out to be a cone. अगर आप 2 degree पे हो तो it will turn 2 degree पे भी आप बहुत सारे बना लेते हो. Circular बना रहे हो तो आपको circular का एक 2 degree पे follow करना होगा. If you are in a parabola 2 degree, you have to follow that way. So हर चीज का डिग्री डिफरेंट है, right? Now coming back to the pyramid, pyramid is something जहां से आपको बेस कुछ भी होगा. Now it's not only cone, it can have any plate surface, any plane surface, but all the plane surfaces are converging to one point that's called apex. Okay, these type of solids are called pyramid. As you can say, this is a cone, it is also a pyramid. You see, this is a tetrahedron. If I say this, नीचे एक triangular plate बना दूं, फिर एक side पे एक triangular plate, दूसरे side पे दूसरा triangular plate, all will converge to one point. That will get tetrahedron. अगर मैं नीचे रखूं, I say नीचे मैं रखता हूं एक rectangle और फिर मैं triangles लगाता हूं चारों edges पे, then also it will turn out to be a square based pyramid, right? So we call it square pyramid. Getting the idea what is tetrahedron? No problem till here? Can you go to the next slide? Now, and if edges of a pyramid are represented by A, B and C, we can have any edges, right? So अगर नीचे triangle बना है तो वो क्या बन जाता है? Tetrahedron. अगर कोई pyramid है, I am just talking about a general pyramid. आपको याद है what is the volume of a cone? 1/3 pi square h. 1/3 बाहर है, pi r square into h. Pi r square into h क्या बाहर है? 1/3. Pi r square क्या है? Area of base. So you understood 1/3 into area of base into height. That is the volume of pyramid. Any pyramid. If you have to find the volume of any pyramid, you just have to find the square base of the area of the base into height into 1/3. So tetrahedron के लिए क्या करना पड़ेगा? 1/3 into triangle का area into height. So does it mean that we can find the volume of triangle? Of course yes. And the answer turns out to be नीचे क्या है? ट्राइंगल है तो 1/3 बाहर आ गया. ट्राइंगल का एरिया क्या होता है? हाफ ए क्रॉस बी और वॉल्यूम क्या होता है? डॉट सी. सो आई गेट 1/c AC. क्लियर? सो वॉल्यूम ऑफ टेट्राहेड्रन टर्न्स आउट टू बी 1/c. ओके, नाउ आई नो वन मोर थिंग दैट A BC is A dot B cross C, A cross. अच्छा एक बात बताओ, when you have created a parallel pipe, तो किसी को भी बेस बना सकते हो ना? किसी को भी बेस बना सकते हो, तो वॉल्यूम किसी को भी बेस लेके तुम निकाल सकते हो. तो अगर मैं कहूं A डॉट B क्रॉस C या कहूं A क्रॉस B डॉट C, कोई फर्क होगा क्या? Only we should follow the vector area thing, that we should not change the pattern. So they will always, अगर A B same है या A B same है या B same है या C A B है, पैटर्न नहीं खराब हुआ. जैसे I J K, J K I, K J I, K I J, इसमें पैटर्न नहीं खराब हुआ. जैसे ही पैटर्न खराब होगा नेगेटिव आ जाएगा. तो राइट हैंड सिस्टम में ABC is positive and BC are in right hand system. When I say right hand system, you understand? A से आप B की तरफ कर्ल करते हो, you get the C. This is the right hand system. A से B की तरफ आप अपने फिंगर्स को कर्ल करते हो, you get the C. That's called right hand system. जब भी ये सिस्टम फॉलो करोगे, the volume will always turn out to be positive. और लेफ्ट हैंड सिस्टम फॉलो करोगे means opposite of this, मतलब इसको जरा सा भी तोड़ोगे, चेंज करोगे, so it will get negative. So I can say clear, which will be equal to minus of, clear. हमने पैटर्न यहाँ पे ब्रेक कर दिया, एक के बाद बी आना चाहिए, सी आ गया अचानक से, एक को जंप करा दिया, पैटर्न ब्रेक, तो नेगेटिव आ गया. क्लियर? सो यू अंडरस्टैंड इसका मतलब वॉल्यूम क्यों होता है, और इसका रिप्रेजेंटेशन A क्रॉस B डॉट C लिखो या A डॉट B क्रॉस C, फर्क नहीं पड़ेगा, सेम स्टोरी. We call this as scalar triple product, and what we call it, क्या होता है ये actually? It's nothing but volume of parallel pipe created by ABC as edges, right? And if the volume turns out to be 0, means the scalar triple turns out to be 0, it means these three are not able to create a solid, which means they are coplanar, right? Can we go to the next? So एक बात और पता चला कि जब हम ट्राइंगल कब नहीं बना पा रहे थे, जब कोप्लेनर नहीं था. ट्राइंगल बनाने के लिए वी नीडेड कोप्लेनर थिंग, और पैरेलल पाइप बनाने के लिए वी नीड नॉन कोप्लेनर्स. ये दोनों का फर्क समझो और दोनों को डिफरेंशिएट करना सीखो, राइट? सो नाउ अगेन इट आल्सो कॉची इनइक्वालिटी जो 6 नंबर के लिए था. अब देखो यहाँ भी कुछ और इंटरेस्टिंग होने वाला है. when I say, okay, tell me which parallelopipe has the maximum volume? Cuboid, because rectangle का maximum area होता है ना, for a parallelogram, अगर edges equal हैं तो. So I say mod of ABC is less than equal to mod A, mod B, mod C. This is the volume of cuboid, and this is simple any parallelopipe, right? So that is obvious now, right? So equality occurs when A, B, and C are mutually perpendicular for the above inequality equation, right? Or the inequation, you say, right? Okay, for the above inequation. Can we come down? So remark is, if A, B, and C have constant length but variable directions, then parallelopipe with maximum volume will be rectangular parallelopipe or cuboid. So I can say this is less than equal to this. Can you go to the next slide? So here is the concept that this is A, this is B, this is C. Okay, can you say that this is this? We'll show you how. Okay? If I say A dot B cross C, so I can say x1 I cap, understood, x1 y1 z1, understood, y है ना, dot I j k x2 y2 z2 x3 y3 z3. Now I am taking a dot, तो ये जाएगा इसके साथ इंटरेक्ट करेगा, तो ये क्या बन जाएगा, so basically this becomes your volume. Understood or not understood? They are on a right hand system. उसी तरीके से रखोगे आप, इसके साथ play on करोगे नेगेटिव हो जाएगा, right? For the right hand system it will always be positive. Understood or not understood? Okay. Now how many real numbers you can see? You see 9 real numbers. Last time you were seeing 6 real numbers. Here you are seeing. So एक जो inequality हमारे सामने आने वाला है, which is true for 9 real numbers. Let's see how. Square is less than or equal to right. This is going to be left hand side, you see a parallelopiped, right hand side you see the cuboid. This is the inequality going to be. So it is true for any 9 real numbers, a very important inequality. So see, from again last time from dot product we found one inequality for 6 real numbers, that was Cauchy inequality, and then now from a scalar triple product with the simple concept of our geometry and maximization, we have created this inequality for any 9 real numbers. Understood or not understood? But can you come down? Okay, my question is, what is going to be the condition for the above inequality of 9 real numbers to become equal? Solve it. Fine. Solve it. When this is going to be equal? When this, if this is when this 9 real numbers equation will be true. If I replace this equal to, then they are going to be true. Last time we proved that the equality occurs when theta is 0. Now these two should be perpendicular, these two should be perpendicular, and these two should be perpendicular. So condition should be dot product should be 0. So x1 x2 plus y1 y2 plus z1 z2 is 0. x2 x3 plus y2 y3 plus z2 z3 is 0. x1 x3 plus y1 y3 plus z1 z3 is equal to 0. Three conditions, right? Understood or not understood? Clear? So पहले तो inequality समझ में आ गया कैसे आया for any real any 9 real numbers और ये इक्वालिटी ट्रू किसके लिए है तो भाई ट्रू तब है जब x1 x2 plus y1 y2 plus z1 z2 is 0 x1 x3 plus y1 y3 plus z1 z3 is 0 x2 x3 plus y2 y3 plus z2 z3 is 0 ये तीनों इक्वेशन अगर ट्रू है तभी ये इक्वालिटी ट्रू होगा अदरवाइज इट विल नॉट बी ट्रू क्लियर इट विल ऑलवेज होल्ड दिस इनइक्वालिटी क्लियर और नॉट क्लियर now since we have already finished our dot product we have already finished our scalar product we have already finished sorry dot we have finished we have already finished cross product we have already finished scalar triple product okay now let's see how to with the scalar triple there is one more identity which you must know about the scalar triple product when I say can you see the question on the diagram it says the identity says that ABC into PQR basically you have a parallelepiped with ABC edges and another parallelepiped with PQR उसके वॉल्यूम्स को आप मल्टीप्लाई करते हो it will be nothing but A dot P A dot Q so it's an identity which you can keep in mind if you go to the proof it's a very basic proof and you don't need to prove it you simply can trust that because this is basically what this is your scalar and this is your scalar scalar into scalar that's a very easy thing to multiply right and it will finally turn out to be A dot P A dot Q A dot R the matrix the determinant value of this right this is very easy to keep in mind because you just have to take dot with all the three then you have to take dot with all the three then you have to take dot with all the three clear so just simply nothing doing but scaling it up scaling your PQR with respect to A, B, C and then finding a new volume. Can you come down? Now here comes the challenge. Find the volume of regular tetrahedron of unit h of each edge. मतलब एक आपका regular tetrahedron है. What is a regular tetrahedron? All the triangles are equilateral. All the triangles are equilateral triangles. Now we have to find the volume of that. कैसे करेंगे? Volume is going to be A, B, C. 1 by 6. अभी 1 by 6 बाद में भी लगा सकते हैं ना चलिए ABC की वैल्यू निकाल लेते हैं ये हो जाता है पैरेलल का वॉल्यूम इसको मैं स्क्वायर कर लेता हूँ कर सकते हैं स्क्वायर क्लियर इससे क्या फायदा हुआ आई कैन टेक डॉट विथ now all are of unit h डॉट प्रोडक्ट क्या होगा h h cos we have a regular tetrahedron so everything has 60 degree this will become 1 or h considering h as 1 बाद में डाल देंगे, ठीक है। 1 clear, and then I can replace this by now it's very easy. What will you get? The square of this. You get the square of this. Just say what we are getting. Cos 60 can be replaced by half, 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 half. That's it. ठीक है, यहाँ तक कोई इशू नहीं है। और एक तो सीधे ऐसे भी कैलकुलेट कर सकते हैं, और आई कैन सी हाफ माइनस हाफ, तो जीरो बना सकते हैं इसको, है ना। जीरो बना देते तो ज्यादा अच्छा रहेगा। तो 1 minus half turns out to be half, half minus 1 turns out to be minus half, ठीक है। Now I can find this thing. This will be half into 1 minus 1 by 4 plus half, because minus of half is plus half, है ना, माइनस माइनस प्लस हो गया, and then half minus 1 by 4, so it will be 3 by 8 plus 1 by 2 into 1 by 4, ये हो गया ना। 1 by 8 plus 3 by 8, that is 4 by 8, half. So your ABC square is, तो ABC क्या हो गया, तो आंसर क्या हो गया, 1 by 6 root 2, 1 by 6 root 2 h cube, 1 by 6 root 2 h cube, क्योंकि हमने h निकाल दिया था। Clear or not clear? Very easy. So we actually use that identity. Otherwise, what is the other way? Draw the diagram, then draw the solid on the x-axis, y-axis, and z-axis. Find the coordinate, and then find the vector, and then took this matrices. So this would have created hell lot of calculations. But this identity helped us keeping things very easy, because we know that all the three are making 60 degree, right? So till today we are finishing up here. So next class we will discuss more questions of scalar triple, and then we'll go to vector triple, and then we'll discuss more questions, and then probably if we finish before time, I think last time we missed permutation combination. Some portions were left, so we try to cover that, and we also had to discuss about the angle bisectors thing in coordinate geometry, right? So probably we'll also discuss coordinate geometry tomorrow. Okay, if we finish up this thing in time. Please revise everything, okay? And PDF will be sent to you. Okay, bye.